So if you're absolutely brand new to game development, a lot of what we talk about and do will be a little bit confusing to you, and that's totally okay. When I first started out, I did not understand anything. I was so confused with the most simple concepts. I didn't understand what variables were. I couldn't understand what functions did. I didn't understand how art was put into a game. How do you put a game on the App Store? These were all very, very confusing for me. So if you don't understand everything perfectly, that's totally fine. Just follow along with the tutorial, and I guarantee by the end you'll have a working game. When you understand the whole concept from a game from start to finish, you'll better be able to understand the concepts that we talked about at the beginning of the session without being overwhelmed. So the first thing we're going to do is go to unity3d.com and click Get Unity. Unity is a free game engine that basically 60 or 70% of all games are made on. You can make mobile games, you can make 3D games, you can make amazing games. It's pretty awesome and free game engine. So we're just going to click Try Personal. Personal is the same as Pro or Plus with just a few little features removed. Like, so for example, we can't have our own splash screen on Personal. You have to have the created by Unity, which is totally fine. My games have got that. Click I confirm, download the installer for Windows or for Mac or whichever operating system that you're on. It will download. You'll see some free assets here to help you get started, some free tutorials. You can open up the installer and just run through that to install the latest version of Unity. Don't worry if you don't have the exact same version of Unity. Anything over this will work fine with everything that we're doing in this tutorial. So don't stress about that. Though, because I've already installed Unity, I'm just going to open it here. But before we do that, I'm going to download the project files. So what are the project files? The project files are things like audio, which is like our theme song. Or it's things like our sound effects, things like our sprites for the game, and just things like that. Little assets that you can't create inside of Unity, but will be used in this project. If you want to use your own assets, that's totally fine. You can use your own sounds, you can use your own visuals. If you want to use all the visuals that are in this project for your own game and release it on the Android store or the iOS store, any type of game, that's totally fine as well. Do it, you do you. Okay, so let's start a new Unity project. So start up Unity. We're going to click New. Make sure you sign in with your account, which I'm sure that you do. We're going to choose 3D template. We're going to name it Balloon Beach. I always spell balloon wrong. Maybe I'm spelling it wrong now, but I'm not going to check. And we're going to check the location. I'm going to choose the location of where to save our game. Choose just anywhere that you feel comfortable saving it on your hard drive. You can leave Unity Analytics on or off. It doesn't really matter. And we're going to create project. Unity will now create a new project and set everything up for us. Okay, so when Unity starts up, this is what you'll see. If you've never opened Unity before, once again, you'll be overwhelmed, but don't worry, we'll get through it. Okay, the first thing we're going to do is we're just going to do a little bit of tidy up. So Unity starts off by creating a folder called scenes. I don't really think we need that, so we're just going to delete that. Then we're going to drag in our project files. So just click them and drag them into the assets window here. Okay, fantastic. So now we have a new Unity project with a, that is all ready to rock and roll. We can press play and see what our game does. Right now it does nothing. It's just a camera in an empty space. We can see over here we have our services. So we have like Unity ads turned off, Unity analytics, which is turned on, which was that question at the start. Cloud builds, a bunch of other stuff that we don't really need to worry about. We can click over to the inspector. The inspector is something that we'll be using for most of the game. So if I click on something like the camera, you can see all the information that we have for the camera that's in the game or the directional light. Over here, we have our scene. We have all the items that are in our scene. Over here, we have our scene view. So we can, if you right click, you can like kind of move around the scene. If we wanted to like, add a cube, we could add a cube and we could like move it around, and you can see over here in the game view, you can kind of see the cube. If you wanted to make the cube bigger, you could come over to the cube up here and drag the X, or you could drag the Y and the scale, make it bigger or smaller. You could do whatever you like. Or you could click these buttons up here. So you could go to hand tool, move around. You got the, don't know actually what it's called, the move tool. We can move it like along different axes, or we can just, grab by that and just move around. You got the rotation tool, which obviously you can rotate, and all of these work with messing around with the transform information up here. So it's all just based on numbers. So for example, if I'll show you an example in a sec, but say if we also wanted to like grab, you'd also grab the scale tool. You could scale things like this pretty simply, and so on. You can just play around these tools if you like. But say if we wanted to, let's just delete this cube because we don't need it. Say if we wanted to grab a new cube, and let's just say cube, and we wanted to make sure the cube was right in the center, we could change its X position to 0, its Y position to 0, and its Z position to 0. And now this is exactly in the center. And we know that the cube is 1 has a width of an X value of 1, a Y value of 1, and a Z value of 1. So if we want to create another cube, copy, paste. Now the other cube is inside that cube. And say if we just wanted to be right next to the other cube, we could just change the X scale to, sorry, not the scale, sorry, the position to 1, sorry. So 1. So then we know that these two are right next to each other, which is pretty cool. The only other thing that we need to worry about, let's just delete them because we don't need them, is down here we have our assets. These are the items, I suppose you could say, like our scripts, our audio, things like that, the things that are actually going to be in our game and included in the build. So if you like make a new song and you want to drag it in, you can just drag it in. We've got our console down here, which is used for debugging code. We'll be using this a fair bit. And we have our animations, which are used for creating like animations, like whatever we want to do, like we want like a ball bounce or something, we can create that in the animations section. Okay, so the last little part we need to do before we get stuck into game development is we need to set up our project to work with the type of game that we want to make. So we want to make a mobile game. So it's pretty easy to do. So first what we're going to do is we're going to go File, Save Scene As, and we're just going to save the scene as main. Cool. So now we can see the scene has popped down here in the Assets menu. So if we click on that, it'll open the scene. Happy days. Everything's going well. Then we want to go over to File, click Build Settings, and it should automatically be on the PC, Mac, and Linux standalone. What we want to do is we want to click on the iOS, or we want to click on Android, depending on what you want to develop for personally. They're both pretty much exactly the same in regards to what we'll be doing inside of Unity. So choose which one, and you want to click Switch Platforms. So mine's already on iOS, but click Switch Platforms, and what that will do is it will move Unity project over to work with iOS. It should take, a couple minutes to do. The next thing we want to do after that's kind of worked, go back into Build Settings, and we want to click Add Open Scene. So you can see here we have that deleted scene that we deleted at the start. We can just delete that. And we added our open scene, which is our main scene. So if we wanted to, say, build our game right now, we could actually build the game, and then we could actually move it over to Xcode, or we can move it over to Android Studio, and we could put it on a phone, and we would actually see this game. That's totally it. Like you've already created a game. I mean, the game doesn't do anything. It's just a camera in an empty space. But that's all you need to do to basically set up the project to work with mobile. And I'm sure you found it interesting that you can also do Xbox One, PS4, Facebook. I mean, Unity is a really, really dynamic game engine. And after you create the project, obviously you have to do a little bit more tweaking in there. In, for example, Xcode or Android Studio to get it to work. But basically, the majority of the work can be done in Unity and exported to all these different platforms. It's really cool. So the next thing we want to do is we want to change our game aspect ratio. So this is like the camera, like what the game will actually look like. And we could set it to iPhone tall, or, if you're on Android, it'll have some different options. iPad wide, iPhone 4 tall, and, it has different resolutions. But for ease of sake, I'm just going to create a new resolution, which is the exact resolution of my phone. I currently have the iPhone 7 Plus, which has a resolution of 1080 by 1920. So if I go down here and press the plus button, I can create a new resolution. We're going to call this iPhone or Android or whatever you want to call it. And I'm going to make the width 1080 and the height 1920 and press OK. Awesome. So now this is what our game will look like. When we press play, that's what the camera looks like. And all of a sudden we've got the correct aspect ratio for our games working on our mobile platform. It's totally awesome. In the next episode, we'll do a bit of a scripting primer for people who have never done coding before or just need a refresher. And we'll also explain how Unity uses scripts and how Unity works to create an actual game inside of the game. So, see you there. So games run off code, of programming. Programming is just instructions that we give the computer to do certain things. So, for example, if I wanted a gem to rotate, I could just tell the computer, hey, make this gem rotate. And that's it. So what I'm going to do is I'm going to create a script just to explain some of the core concepts of programming and what Unity does with those lines of code, but with those instructions. You don't need to follow along with this section because we're just going to delete the script afterwards, but I'm just going to use it to illustrate a point. So if we right click and if I right click and just go create new C# script, we're just going to call it test. Going to open that up. It will open up in Visual Studio or another code editing software. Once it's open, you'll see a bunch of different lines that are already in there. Don't worry, you don't need to worry about any of these too much, but I'll just quickly go over them. These are your namespaces. These are basically telling what packages are going to be included in inside of the script here. So we could add more to this or we could add less, but in general, we basically don't touch this. Then we have our class. Our class is basically the script in itself. It's basically the big, how can you say, think of it like all the instructions will go within this class here, and the class is called test, and it derives from mono behavior. So just quickly, another side note, your code might look a little bit different to mine here. If we click here and I press space and backspace, your code may look like this. This may be how Unity has or Visual Studio has formatted your code. You can change these settings so it looks like mine in debug options. And you can go through and you can get the code to format however you like. This just happens to be the way that I like to format my code. It's for the open curly brace to be on the same line as the method, and the closed curly brace is on the end of the method. However, this doesn't actually affect the code at all. So this just makes it look a certain way, but it doesn't actually affect how the code runs. So if you want your code to look like mine, you can go to debug and options, but if you just want to leave it as is, that's totally fine as well. It won't affect how anything runs. Just make sure you understand that your code will look like this and my code will look like this. Awesome. Then we have two functions. We have void start and void update. And on top of those, we have comments. These comments can be anything. If you just put 2 slashes, you can write anything and it won't be affected by the code. So for example, I could write this method or function and method are basically the same thing. You might hear me say either one. This function or method or function, happens once at the start of the game. And this method or function happens every frame of the game. So if we wanted to write something out, if we wanted to write some code that would actually do something, say if we wanted to, create something that happens once at the start of the game, we could put it in here. So we could press enter to do a new line, and we could write debug.log. Open bracket, open speech marks, and we could say, this is the start function working. And in the line, we want it closed off by using a semicolon. Cool. So then if we go back into Unity and we just drag this script onto the main camera, it could be literally in any object in the game, but we're going to just drag it onto the main camera. And we're going to go over to our console. What we're actually asked to do is we've asked it to, when the game starts, we want to run this line of code, debug.log. It's going to log some information to the console, and the information that we're going to log is this statement here. So if we go over to the console, press play, we should see that's unmaximize on play. Should press play again. This is the start function working. Cool, so we've written our first line of code. Now what if we want to write something in here? Well, let's just copy and paste this, debug.log. And we have a script here. This is the start function working. Well, this is the update function. We'll say this is the update function working every single frame. Save this, press play, and you see we have start being called once, and we have down here, this is the update function working every single frame, and it's happening every single frame. Cool, so they're the basics of how start and update work. But if we wanted to create our own method, that's totally easy as well. We could say something like void our own method. Just got to make sure it has these and the two curly braces, and the two curly braces, anything we put in between this will be our method, our own function. So we can put whatever we want in here. So we could copy a debug.log and we could chuck it in there, and we could write this is our own method. Save that, go back over to Unity, press play, and bam, nothing happens. We have the start function working and we have the update function working, but for some reason our other function isn't working. I wonder why that is. Let's go back over to the script and find out. So we have void start, void update, and void our own method. Now, I could have named this whatever I wanted, but I just chose to call it our own method. But the problem is this isn't being called at any time. Update automatically calls every frame. Start automatically calls at the start. And there are other things like awake that gets called before start. But we need to actually call this. So if we want to call this once, well, we could put it in start. Or if we wanted to call it every frame, we could call it in update. Let's just call it in start for now. So we're going to say our own method. Done. So then we've just called this method from start. So when the game starts, it will call this line of code. It will move down to here and do this instruction. So press play. This is the start function working. This is our own method. This is the update function working every single frame. So that's a quick primer on basically how code works inside of Unity. Now, obviously, in the real world, we'll be doing some different. In the real world, we won't be just doing debug.logs. We'll be doing things like moving objects or rotating things or making collisions work. And all those things are pretty simple to do inside of Unity. They're just lists of instructions that we need to do. And it will be overwhelming if you've never done coding before. But just trust me, follow along. By the end of the entire project, I guarantee you'll be much more confident. Tune in next video for an explanation on variables and how they work in our game. So we are just going to delete this script that we just wrote. And we're going to go over to main camera. We'll notice that the script now is saying it's missing. So if we just highlight over that and click remove component. And we're just going to explain exactly how variables work inside of Unity. So let me create an example. So I'm going to create a new script, new C# script. I'm going to call this variables. Let's open that one up. Okay, so we're started with the same template, but this time our class is called variables. And I'm going to show you a few different types of variables. So to start a variable, we say public. We can also say private, but just for simplicity's sake, we're just going to name more public for this at this stage. Public int whole number. Actually, let's call it something different. Let's call it car speed equals 45. Cool. So an integer is a whole number. Sorry, this keyboard is really hard to type on. And then we've got a different type of variable, a public string and we're going to call this player name equals Dave. And we got another variable called public bool, and we're going to call this is player in boundary. And we're going to equal that to true. Okay, fantastic. So, a string is basically just like, let's just call it text for now. That's probably the best way that you can understand. It's just text. It's just a packet. It's just a container that holds the information Dave. This is just a container that holds the information 45, whole numbers. And this is the information that holds a true or false statement. Okay, so this is probably very confusing, and I totally understand why, but if you've never done programming before. But if you have done a little bit of programming, it should make a little bit of sense. The variables are what we use to store information and manipulate the game world. So, for example, if we had a car that was going at 45 and then the car crashed into a wall, well, then we could say, this isn't actually code, but let's just say it was code. We could say if car crashed into wall, then we could say car speed equals 0, because the car would then be going at 0 speed. That line of code won't work. Don't use that. That's actually garbage. That doesn't work. But it's implementing a point. So what we do is we ask questions to the computer. Well, how fast is the car going? Well, if the car's going at 45, then we want to move that car object at the speed of 45. Is the car in the boundaries? Is the player in the boundaries? Well, if it is, then if it is, then all good is true. But if it's not, then we need to do something. So a real world example is, say we have a car traveling down a track and the car drives out of bounds. And what we want to do when a car drives out of bounds is just like it happens in Mario Kart, the video game, where when you drive out of bounds, the car gets picked up and put back onto the track. Well, if we wanted to do something like that, it's pretty easy. We could say inside of update, we could say if, this is what an if statement is. So it's asking the computer if is player in bounds equals, two equals signs, asks the question of it equals. If car is in bounds equals false, open up curly braces, close curly braces. Then we want to say, then we can say something like, move player back to track. And that's it. So that would mean that as soon as this is ticked to false, the player would get moved from wherever they are out of bounds back to somewhere that we put on a track. So if you look at these variables here, we have a float, a string, and a bool. A float is like an integer, but they're like decimal place numbers. So an integer can't do decimal places, but a float can. So you can have like 4.2, 45.6. So they're a lot better for doing things like car speed. A string is the car name. It's just Red Boy, which will be the title of the car. And a bool is like the bool that we were talking about in our script. Is car in bounds? Yeah, is car in bounds is equal to true. This car name is equal to Red Boy, and the car speed is equal to 45. Let's see what happens. Okay, so you can see here in this example, we have a car traveling up the highway. The car is going at the speed of 45. Its name is Red Boy, and it's inside the bounds, so everything is working fine. So in that situation, we have used 45, the variable car speed, to determine how fast the car can actually travel. We're saying, hey, the car speed is 45, therefore make the car travel at the speed of 45. Pretty simple, right? But how do variables actually work to affect the gameplay? Well, look at this next example. In this next example, we have the exact same situation. The car is traveling at 45. His name's Red Boy. And is car in bounds equals true. But let's see what happens when the car drives onto the dirt. Watch the float car speed variable. It's 45. Car speed goes down to 20. So as the car's driving along, still driving at the only speed of 20, he's going to drive out of bounds. Look what happens to the ball is car in bounds. Turns false, and also the car speed turns to 0. So what happens then is the game goes, okay, the car is out of bounds, so let's move the car from where it is now back onto the track and put the car speed back up to 45, and the car can burn around that corner and speed off into the horizon. Everyone is happy. Happy days. So that is just a quick example of how variables are used in a game engine to determine how things work, to determine the logic of how the game works. Okay, so it's time to throw you guys into the deep end a little bit. I've just deleted the variable script and our project is back to where you guys should have it. And I want you guys to create a new script. So create C# script. You guys can call it whatever you want because we're also going to delete this. Okay, so I'm going to show you guys how to do something pretty interesting. I'm going to create a variable called public bool. Is Dave a good bloke? That's going to equal to false. Sad. Then we're going to go down to the void start, and I'm going to say debug.log. I'm going to open and close some speech marks and say, is Dave a good bloke? Question mark. Put a space in there. And then after the speech marks, I'm going to say plus, and I'm going to add the variable, is Dave a good bloke? So what it's going to do is it's going to say, it's got a variable that says, is Dave a good bloke? Is Dave a good bloke? Equals false. And then it's going to log out, is Dave a good bloke? And it's going to tell us our answer. So if we go back to Unity and drag our script onto the main camera and press play, and we move over to our console, is a Dave a good bloke? False. That's sad. So what we're going to do is we're going to change that variable. So after we've logged it, is Dave a good bloke? I'm going to write, is Dave a good bloke? Equals true. Cool. And then I want to copy this and I'm going to paste underneath. And I'm going to say, is Dave now a good bloke? Go back over to Unity and press play. Is Dave a good bloke? False. Is Dave now a good bloke? True. So what's happened there is our variable, is Dave a good bloke, started as false, got printed out as false, got changed to true, and then got printed out as true. So for the test, I want to see if you guys can do the same thing, to see if you guys can create a variable, get it to log out into the inspector, change that variable, and then log it out again. You can use any variable you like, you can call it whatever you like, and you can change the value to whatever you like. Give yourself 10 minutes to complete this task. If you get it done in 10 minutes, hey, happy days, you're pretty good. If you're still struggling, that's totally fine as well. You'll eventually pick it up. In the next episode, we will start coding the actual game. This is where the project will pick up at a faster and faster pace. So soon, we'll have a working prototype that you'll be able to show your friends and family. See you there. Okay, so let's start actually working on the game. This is where it gets exciting. So let's delete our script, whatever. We don't need that. That was just for the test. And we're going to create a couple of new folders. So we're going to create a new folder called Materials. This is just for organization. We're going to create a new folder called Scripts. You don't have to create these folders, but I just like to keep things organized. So inside of the Materials folder, we want to create some materials. So I'm going to create a new material. I'm going to call this grass. And I'm going to create a new material by right-clicking and choosing create a new material and calling it water. So with the grass, I'm going to come over to click on the, either one, click on grass, come over to the albedo here, click on this little color wheel, and I'm going to just choose like a nice enjoyable green color. And for the water, you guessed it, I'm going to choose a nice, simple blue color. Cool. So we created our two materials. And now we're going to create just a plane to do some testing for our ball to roll on, like to get the ball going, right? So we're going to go over to game object and we're going to create a new 3D object. We're going to create a new cube and we're going to call this cube. Actually, we'll just call this ground for now. We're going to change its position to 0, 0, 0. And we're going to change its scale to just something that we can work with. 100 on the x-axis and 100 on the z-axis. And you can see it's incredibly bright. It's something that it's much too bright. It's completely white. So in our scene, so if we zoom out here, you can see we have just a big flat white cube basically. And we've got a directional light here that we can, change the colors, change the direction, things like that. And we've got a main camera. So with the ground, we just want to click on the ground. And over here, we'll see the components that are on the actual ground object. So we have a cube mesh filter, we have a mesh renderer, and we have a box collider. So the collider is what we use to detect whether objects have collided with the object or whether or not they're inside the object if you click in is trigger. And the mesh renderer is just rendering the actual mesh of what the actual object is. So if you see under the mesh renderer section, we have a section called materials. If you open up that material, you'll see that it has an element, and that element is just the default material. That's what's painting it all as white. If we click and drag our grass material over, you'll notice that it turns green, and it looks much better in my opinion. So that is just a quick and dirty way of getting a material to look a little bit better in Unity. Just creating a new material, changing its color and just dragging it onto the cube. And now we have an environment that looks a little bit better to work in. In the next episode, we'll start our first script and we'll get the ball rolling. Pun intended. In this episode, we're going to get some movement happening. So the first thing we want to do is create a new game object, and we're going to create a 3D object, and we're going to create a sphere. We'll call this sphere player. And we'll center the player. So we double click, you'll see that the player is right inside the ground. And that's because our ground is actually at the same location and it's actually the same height. So if we actually grab the ground, drop down the Y position down to -1, because that'll make everything perfect. Cool. So we have our player at 0, 0, 0, and our player has a mesh renderer, which makes it look like that. It has a sphere collider, and just to make things pretty, let's create a new material. And call this player temp. I just cannot stand that white color. And let's go over to the sphere and go over to material and drag the player temp color. Let's change that to a color you like. Let's just say, oh, that's pretty gross. Let's say, yeah, red. Red works. You can see pretty clearly. And then we're going to grab our player. You'll see it has a mesh renderer, it has a sphere collider. And if we press play, the game does nothing. We haven't told the game to do anything, so that's what we would expect. So if that's what's happening for you, hey, everything's working well. If we go to our console, we should have nothing here. Oh, we actually have two errors. The reference script unknown is on the behavior is missing, and a reference script on behavior game object. Okay, so let's go over to our main camera. Oh, that's the script that we deleted, and it's still trying to access that, so we just need to remove that. Cool. It's good to see the debugging process sometimes. We press play again and go back to... Sorry, get out of play mode and remove component and press play. Cool. Now our console should be absolutely free and clear. So we have our player, and our player just sits there, nothing happens. And that's because we haven't told the character to do anything. If we drag the character up, let's say a little bit, press play, nothing happens either because we haven't actually told Unity that we want gravity to affect this game object. And it's really easy to do that inside of Unity. We can just add something called a rigid body. So if we click on Add Component and click Rigid Body, not Rigid Body 2D, make sure it's Rigid Body, and we'd click Use Gravity and Mass and just all the exact same settings that comes as default, and we press play. Bam, it falls down till it hits the collider that's on the ground, and it doesn't move any further. Awesome. Now we have physics working in the game. Now, given they're not amazing physics, but they're still physics nonetheless. So now we want to go over to our scripts folder. We want to right click. I'm going to create a new C# script, and we're going to call this player with a capital P. It's best practice to name your scripts with a capital, because that's the class name, and classes usually start as a capital. This is just good scripting practices. And so once we've created a script called player, we want to double click to open it in Visual Studio, and we can get to programming. Okay, so the first thing we want to do is just get the player to move. So I'll just zoom in a little bit. And we probably don't need the start. We'll just leave the start and we'll go into the update. And what we want to do is we want to actually access this player. We want to access the component rigid body on the player, and we want to tell the rigid body to move it in a certain direction. We want to add a certain force in a certain direction. So if we go back over here, we can actually say get component. Inside these two little triangles, I forgot what they're called, type rigid body, open parentheses, close parentheses, dot velocity. So we want to just choose what the velocity is. And we just want to equal that to vector3 dot forward. And we want to times that by, let's say, 1,000. And we want to times that by time dot delta time. So what's happening here is we're getting a component that this script is attached to. We're accessing the rigid body. We're accessing the velocity on the rigid body, and we're equaling that to a new vector3 dot forward. So that just means that's just a direction. So we're saying the velocity equals this direction, and we're timesing that direction by 1,000, and then we're timesing that by time dot delta time. Time dot delta time is the time passed since the last frame. If you want something to move at a constant velocity, speed for instance, multiply that by time dot delta time so you get consistent results. If we then save the script and we go back over to Unity, we press play, nothing will happen. Well, our play will fall to the ground. But if we actually, and the reason nothing happened is because the script isn't actually attached to the game object. So what we can do is we can actually click on the player script and just drag it over. Or we could add a component and we could type in player and you'll see our script pop up there. Either one works just fine. And let's get our player. Let's drag them back down to Earth at 0. And let's press play and it should move forward. Awesome. Yeah, it moves forward quite fast. And we can't control it yet. But in this episode, we have looked at how to get a script attached to a game object, and we've got that game object to move forward at a constant rate. And we've added some physics to that game object so it falls down from the sky. So everything is going well. In the next episode, we'll touch on how to control the ball and its direction. Okay, so to get some movement happening, let's double click on our player script. And we're going to create a couple of variables at the top here. We're going to create a public float, and we're going to call this player speed. If you start with a small p or small letter, and then you whenever you write a uppercase letter, it will actually split that. And the reason we say public is so that we can access that in the inspector. So if we go over to the inspector and we go over to the player, you'll see that we have now a player speed variable here, and you'll see that it's split at player, speed, and it looks nicely formatted. So these are just coding best practices. And we want to create a, we don't need to access this in, actually we'll create we'll make it so it's public. Public float directional speed. Okay, so now we have two variables, player speed and direction speed. So player speed will deal with like how fast the actual ball is, the player is moving forward, and the directional speed will be how fast it moves left and right. So we actually are already using we're already using this number somewhere, right? So we're actually using it down here. We're timesing vector3.forward by 1,000. We can change this 1,000 to player speed. And if we press save and we go back over to our game, you'll see that we'll should have two variables here pop up. And if we press play, you will notice something very interesting. First of all, nothing happens. Why is that? Nothing's happening is because the public float player speed, we are now timesing vector3.forward by player speed. And player speed currently equals 0. So what happens in maths when we times something by 0? It equals 0. So if we can actually change this in here. So we can actually drag this forward and forward. And you'll notice that at 184, that's how fast our player is moving. We can make this 1,000, and that's how fast it was moving before. Or we could actually make it negative 500. And yeah, they're all numbers. They all do stuff. And negative 500 means it's actually moving backwards, but you can see now it's under the floor. You get some wacky results. We can actually create the default in here. So let's say, because we were using 1,000 before, that was a little bit fast. Let's say 500. So we can say equals 500. So now it should default as 500. If we want to go back over to the player script, we can click reset and it will come up as 500. Now, whatever adjustments we make here will then override whatever number is in here. So just make sure, sometimes it's a bit of a gotcha. You'll be wondering, why isn't my strip working? Just make sure that this number here, or this number here more is the number that you actually want it to be. Cool. So the next thing we want to do is we want to actually create a float. Now this float will only be used inside of updates, so we don't need to actually declare it up here because it's not a class variable. It's not a variable that's going to be used throughout the whole class. We're just going to be using it once and then basically throwing it out. So we're going to create float and we're going to call it move horizontal. I hope I spelled that right. And we're going to equal that to input dot get access, open parentheses, and then we're going to open speech quotes, and we're going to type with a capital horizontal. And once again, close every line with a semicolon, and we're just going to debug that out. Debug.log move horizontal, so we can see what's going on. So if we press play, ignore the game object for a moment, and we're going to go over to our console. We'll see that we have 0. Now, if you press right on your keyboard, so click on the play game, and press right on your keyboard, you'll see that it goes up to 1 and to -1. And, it changes when you press left and right on the keyboard. This is because we're accessing the Unity inbuilt function called input. And we're getting information from the keyboard and we're assigning it to a variable called float, a float variable called move and horizontal. So we can get rid of this debug.log. And then the next part might be a little bit confusing. We're going to write transform.position. So what is the transform.position? So if we go back over to our player, we'll get a bunch of errors pop up if you've done what I've just done there. Don't need to follow along, but just watch. If we go over to our player, we'll see we got our transform up to here. So once again, we're accessing something on the game object. We're accessing the transform and we're accessing the position. So we got an X value, we got a Y value, which is up and down, and we got a Z value. And we're just going to zero all those out. And we go back over the script and we're saying transform.position. So we're saying, well, we want to access this thing and we're going to equal that to something. And what are we going to equal it to? Well, we could equal it to vector3 or forward or something. We could equal it to a bunch of different things. But what we want to do is we want to equal it to a new position. So what we're going to say is vector3.lerp. So lerp is linear interpolation. So it basically is a smooth movement between two different spots. And right now you can see it's asking for a vector 3A position, a vector 3B position, and a time it's going to take to get there. So this is confusing you. I don't blame you. This is the kind of stuff that you learn, well, you learn more and more as you get better at programming. This is just the syntax that Unity uses to control certain things. And if you're brand new to programming, all of this will go right over your head, but just follow along, do exactly as I do, and we'll get there in the end. So the first position we want to lerp from, well, is just the position that we're at. So we can say GameObject.transform.position. And then where do we want to go? Well, we want to go to a new vector 3. So this is where it gets even extra tricky. So for example, we want our player to be able to, if you watch this, this game view here, we want the player to be able to move forward. So, well, we can't actually play because we're getting some errors, but we want to set the player to move in this direction here, right? Well, this is actually backwards. So we want it to move forward. And we want it to be able to move left and right with the controls, but we don't want it to be able to move all the way off the screen, like way off here, because that would not be fun. So we want to actually clamp the position of where it can actually move to. So like say maybe here and maybe here. So it can only move to the different sides of the screen. But we want it to be able to move as far as it wants in this direction. So this one line of code will do all that for us. So it's a pretty sweet line of code. So we're accessing the transform position equals vector3.lerp, GameObject.transform.position, which is our position now. We want to change that. We want to move from our current position, from our GameObject.transform position, to a new vector3. We want to clamp that new vector3 with mathf.clamp. And it's asking, well, what do we want to clamp? We want to clamp the GameObject.transform.position.x. So we're accessing the x variable plus move horizontal. So we're now accessing the variable that we declared up here, which is our horizontal axis. Put a comma in, and I'm going to do minus 2.5f. So that's minus 2.5, and because we're using a float, you put the f afterward, comma 2.5. Awesome. So that then clamps our position, and then we want to go past the parentheses and put a comma in, and we want to write GameObject.transform.position.y. Remember where it's asking us for a new vector3. Oh, and we forgot the f here. And then we want to say GameObject.transform.position.z. Close, parentheses, comma, directional speed, which is the variable we declared at the top, times time.delta time. And we want to close those parentheses. So I'm going to zoom out a little bit just so we can see the whole line of code. And it's quite a long line of code. So we're accessing the transform position. We're creating, and we're saying, hey, that the transform position of our player game object equals a new, equals vector3.lerp. We're lerping, which is moving smoothly from one position to another. The first position we're moving from is the current position of our player game object. We're moving to a new position, which is a new vector3. The x value on that vector3 is clamped between negative 2.5 and 2.5. Our y position is just whatever the y position is. The z position is just whatever the z position is. And we're timesing that by directional speed times time.delta time. So the only other thing we need to do is assign our directional speed. So we can go up here and write equals, say, 20. And go back over to Unity. Make sure it updates. Reset. And if we press play, we should be able to move left and right. And I'm just going to right click on the scene view and whip around just so I can see in the direction, see the ball in the direction that we're actually moving. And let's just drag it right back, and let's just get the camera and drag it right back. We can actually bring it up a little bit, and we can actually point it down a little bit. Cool. And if we press play, move left and right, and it stops at a certain position. So if this episode went way over your head, I don't blame you. This is one long line of code, but it's just a really quick and neat line of code. If your project isn't working properly, make sure you copy everything exactly the same. The capitals need to be the same. The points need to be the same. You need to use commas at the right positions, and you need to be using everything here typed exactly the same, and it definitely will work if you've got everything typed exactly how it is here in this script. So that's it for getting a player to move left and right and forward. In the next episode, we'll handle mobile controls. Okay, so to get mobile controls working, it's actually pretty easy. So we're going to open up our player script once again. And what we're going to do is we're going to create an if statement just in the update here. So the reason we're doing this is because when we're playing the game on our mobile, we don't actually need these 2 lines of code here. So we're just going to write hash if unity in big capital underscore editor, or, and so the way you do or is 2 of these vertical lines, or unity standalone, or unity web player, and then we're just going to write, under this we're just going to write hash end if. So this is not common code. This is not something that you would see all the time. So if it looks a bit strange to you, hey, it is what it is. So if we go back over to Unity and we go to the console, press play, just check that everything is working fine. Yep, everything is working fine still. Code's been saved. Everything's good. So this just means that these 2 lines of code won't actually, nothing will happen when we're playing on a mobile device. These will only happen in the Unity editor, Unity standalone, or a web player. Standalone is like Windows or Mac or Linux. Cool. But we still wanted to move forward in any case. Underneath that, we can actually write a note to for ourselves and just write two commas and write mobile controls. And then we want to create a new, we want to create an if statement. So an if statement is obviously like you're asking a question, and if that statement is true, then continue on with that, the code within that if statement. So we just want to check if input, we're using the input class again, like we used for up here. If input dot touch count is greater than 0, then close parentheses and open curly brackets, press enter. So then what that will mean is whenever there's any more than 0 fingers touching the screen, do whatever's in this code. So we want it to run only if something's touching, right? And the screen. And so it's saying if touch count is greater than 0, do the stuff that's in this code. I'm just going to neaten this up here by closing that. So it just looks a little bit neater. Cool, but before we actually do the code that happens inside this if statement, we need to actually create a variable. Another variable that's just a throwaway variable, a variable that's only used within the update method, or in this method, which is the update method. And that's going to be a vector2. So what is a vector2? A vector2 is an X and a Y position. So we're going to call this vector2 touch. Touch is going to be equal to camera dot main. So the main camera dot screen to world point and we're going to say input dot mouse position, which is a bit deceptive because it also works on mobile, plus new vector 3 0 0 10. Well, comma 0 comma 0 comma 10 F. Awesome. So we're creating a new vector tool called touch. You don't need to understand everything that's going on here, except for this is basically getting the location of where we're touching on the screen, and it's storing it in a variable called touch. And then within this if statement here, we need to say, well, if you've got more than one finger on the screen, we're going to just simply say transform dot position equals new vector 3. And the first position of the new vector 3 will be touch dot x. So that's part of this touch variable. So touch, the x position of this touch variable, which is our finger position. And transform dot position dot y, because we don't need the y position of our finger. We're just moving it left and right. And then transform dot position dot z, and that's just saying, just basically, you just stick with the default, because we're creating a new vector 3. Cool. And that is it. So now we can actually test this out. So let's go over to Unity, make sure we've got no errors. I'm going to press play. And obviously we can't test it out yet. We got a null reference error. Okay, so let's go over to this. You see it highlighted player. Click on player. Double click. Okay, so it's saying that our camera.main.screenwell to point. I'm guessing that it's actually going like, well, I don't know which is the main camera. So to fix that, let's go check out our main camera. Click our main camera. And we can see that it's not actually tagged as main camera. So we want to change that. Let's see if this fixes this. Go over to the main camera, click tag, and assign it to main camera. So now Unity knows that when we say camera.main, we're talking about this camera because we've tagged it with the tag main camera, which is the default tag in Unity. Let's see if it works now. Press play. Awesome. Now we have no errors. But how do we test it? Well, we need to actually test it on a mobile device. So Unity actually has an app for this on both Android and iOS that you can download. It's called Unity Remote 5. And then all you need to do is plug in your device to the computer, and it should show a screen like this. And then you press the play button, and then it will play the game on the screen, and you'll be able to test out if your touch inputs are actually working. If that doesn't work, go to Edit, Project Settings, Editor, and you should be able to choose your device from this section here. If it's plugged into your computer, it should appear here, and you should be able to select your device. And then you'll be able to test out that the controls work perfectly. If for whatever reason you're having trouble connecting your device to the computer, and you for some reason can't get it to connect and it's not working, don't worry, because this is the only line of code that we'll be using to actually test for the mobile controls, basically. So as long as you've got this written here, it means that we can continue on. And when we get to the stage where we actually export our game and put it on the mobile devices, you'll still be able to continue on with the course without any troubles, as long as you've written exactly what's here. Awesome. So everything should be working fantastic. Okay, and the last little thing we need to do to get our basic movement working correctly is to make the camera follow the player. And we'll do that in the next episode. So I hope everyone's following along with at least 10% of what we're talking about. So for this test, I'm going to challenge you guys with some stuff we've learned in previous episodes. I want you to open the camera follow script back up, and I want you to get the distance between the player and the camera, and I want you to store that in a variable here, obviously, a public variable, so that you can change it at runtime on the script here. So for that, you'll need to create your own variable, assign the variable in this line of code here, and then be able to adjust it within the inspector. Spend no more than 10 minutes trying to complete this task. If you struggle to implement your own code, that's totally fine. Just take the extra code that you did write and delete it so your code looks exactly like this again, and then we can continue on with our lesson. Otherwise, congratulations on learning to be a master programmer. Okay, so before we start talking about prefabs, I want to just adjust the level a little bit and make it look a little bit more like the finished product that we're going to be dealing with, because dealing with prefabs is, as I'll explain later, it works a lot better when you've actually got a good scale of how the level is meant to look. So right now we have a ground and we have the directional light, main camera and the player. But this ground isn't actually how wide we want things to be. So, first thing I'm going to do actually is I'm going to open up the project files here. I'm going to copy all of these. Just drag them into the assets. And when I click on the assets folder, I'm going to delete the projects folder. And then you'll see that we have all of our folders just all neatly stacked here. Then I'm going to want to do is I want to get the ground, and I actually want to make the ground about 7 wide and about, say, 1,000 long, because that's about how big we want the actual level. That's about how big we want it to be just for testing purposes. And the other thing that we want to do is we want to create the water. So I'm going to click copy, paste. I'm going to copy the ground. I'm going to call it water. And the only difference is I'm going to make this 1,000 wide, and I'm going to choose a new material, which will be water. And you see we have some weird overlapping here, and if we press play, you'll see some flickering and stuff like that. The reason that is because both of these are in the exact same position. So we just want to get the water, and we just want to drop it down by 0.1. Awesome. So now we're like scooting along, and we can move left and right, and we fit pretty well on the green area because of that clamp code that we wrote in a few episodes back. And say if we were to drag, like say, let's get a cube and just bring that up. I don't know why it's so low. Cube, let's bring it there, and we press maximize on play so we get the full impact. You can see that in fact, although it is a bit slow, maybe we do need to bring it back up to 1,000. We can go up to the cube and run into it. So there is a little bit of movement, so that's good. So now that we have our project looking like this, it's time to jump into prefabs, and I'll explain exactly what they do and how they work. And then we can get to creating our first enemies or, say, obstacles. See that? So back in Unity, we can see that we can instantiate things like we can, create things like cubes or spheres or things like that. But what if we want to create, say, a enemy that just pops into existence or something like that? Well, we actually need, an enemy has got animations and scripts attached to it and all these different things, and we can actually combine all those things together into what we call a prefab. What a prefab is basically a combination of all the elements that, an object needs, and then you can instantiate or create or spawn that thing into the world. So to give you an example, let's just delete this cube because we don't need it. Let's create a new folder called prefabs, and this is just for organization's sake once again. Let's open up the prefabs folder. Actually, no, let's go back and let's open up the models folder. And we have this model here called triangle. So if we just drag this triangle into the hierarchy over here, should pop up around this location. So what we can do is we can just drag it forward a little bit. We can change its Y position to 0. We can change this to -90 because that's what I think it's trying to do. And in fact, let's get the triangle and let's bring it back down to the play level. That's about the size we want. And let's press 2. Awesome. So I think that's actually a good size and location for the prefab. So right now the prefab has on it a mesh renderer, and it's got a certain material. And what we want to do is we want to go over to materials. And we want to create a new material for the triangle. So create material, triangle. and we can change the color. I'm just going to use like a dark gray because I think that looks, I'm just going to use a dark gray because I think that looks best. And then if we go over to triangle, we can then obviously drag the material so it looks like that. I think that looks pretty good. So what we want to do is we want to just turn off the player for a second, and we want to get the triangle, and we want to put the triangle at 0, 0, 0. Rotation should be negative 90, so it rotates like that. Otherwise, we could have it like this or something, that we're not going to do that. Just keep it at negative 90. Scale 100. All these things look good. These are all the defaults. And then what we're going to do is we're going to go over to the prefabs folder, and we're going to just drag in triangle. Cool. So this is our prefab of our triangle. Now what we can do, you can see it's turned blue here, which means that anything that we do to this, you can click apply and it'll apply it to this prefab, or anything you do to this prefab will affect this. So for example, if we decide to change the texture to the water texture, it actually is going to change each instance of the prefab. So let's drag a few more in here. Cool. So we got a bunch of different triangles. Now we can go to the triangle prefab. Instead of changing the texture, the color on all these different triangles, we can actually just change it on the prefab. We can change it to whatever color we like. So that is what a prefab does, and that is what a prefab is. In the next episode, we'll look at how to use prefabs to create randomness. Okay, so I've deleted all the triangles out of the scene, and I'm just going to drag the triangle back into the scene. So you'll see here that the triangle's at 0, 0.27, and 0. So you can see, I think it was before it was a little bit low, so I just bring it up to 0.27. It might be different for your project, but just make sure it's like sitting flush with the ground just so it looks nice. And so we have the triangle right here, and let's just bring it forward a little bit, and let's turn our player back on, and let's see what happens when the player runs into it. Okay, the player goes straight through. That's not good. So what we want to do is let's look at our triangle and see what's on our triangle. So we got our mesh filter, we got a mesh renderer which renders it to the screen, and that's basically it. We don't have anything else. So what we want to do is we want to add a mesh collider. So you can just type in mesh collider. You could use, say, for example, a square collider if you wanted things to be a little bit simpler, but this should be pretty good. It's only a triangle. So then if we press play now, you'll see what will happen. Cool. Our player goes over the top. That's really awesome. So because our world is always flat, we never ever want our player to be able to move up or down. So we can actually go over to our player, go down to rigid body, we can open up constraints, and we can actually freeze position on the y-axis. So press play again, and you'll see it's just rotating in spot there because it can't move up and over, and that's exactly what we want. Fantastic. So now we have a triangle. Well, how do we use them to create randomness? How do we use them to create the game that you guys saw at the beginning? The finished project. Well, we need to actually create a few different prefabs, a few different instances. So we have our generic triangle here that just is all great, but we need to actually create like sets of triangles, like a grouping of triangles, and then use them as prefabs. So how we're going to do that is let's turn off our player again. And let's turn our triangle, let's bring our triangle back to 0 on the z-axis, so it's right in the middle. Let's just bring it here. Just like to position the camera a bit better, just so we can see what was going on. And let's get our triangle, and let's copy it and paste it. And we're going to put this one at position 2, and we're going to put this one at position -2. So then we've got a gap through the middle. Awesome. So then we also want to create an empty, and we want to make sure you zero this empty out, 0, 0, 0. and we can call this triangles underscore A. And we can grab these two triangles, which if they're at the perfect position, drag these two triangles into triangles A. Triangles A should be at 0, 0, 0 for everything, and then we should have -2 and 2. And then we'll be able to actually drag this, we can drag this forward and back. You can do whatever you want with it. You can move it off to the side, but now it's grouped together. Well, that's awesome, but what else do we need? So we need, so we've got the two colliders here, so that's all great. And we want to actually tag these triangles with a special tag. So when we run into them, we can actually, create a game over screen. So if we click on one of the triangles and we go up here and we click on the tag and we click open tag, we click the tag button here and click add tag, we can have a list of tags here. We can click the add button and we can call it triangle with a lowercase t, triangle. And then we can go over to our two triangles and we can set their tag to triangle. We can go to our prefab. We can set that tag to triangle. And so now whenever we run into it, we can actually access this through code and we can ask the question, hey, have you run into something with the tag triangle? And then we can use that to form our game logic. So the only other thing we need to do is we need to create a center section. So the center section will be where we get the score. And we just want to make sure, so whenever the player passes through the center section, he gets she or he gets 1 point. So what we can do is we can create a new 3D object, create a new, let's create a new empty. Let's grab this empty, 0, 0, 0, make sure it's absolute center. We can call this gap. We can drag this gap onto triangles A. Once again, triangles A should be at 0, 0, 0, and all these should be at -2 on the X, 2 on the X, and 0, 0, 0. So it's right in the middle. Then all we need to do is add a box collider. And you can see here, I'm not sure if you can see because it's also green, but you can see here we have a box collider. Now all we need to do is click is trigger. And then let's see what happens. So if the player runs into the section, that's fine, but it still can go through the center. The reason it can go through the center is because we've turned is trigger on. If we didn't turn is trigger on, the collider would act like a collider. Bam, we ran into the collider. But because we've turned is trigger on, we can pass right through it. So we'd use another separate line of code to say, are we in the trigger zone gap? And if we are, give it a point. And so that's how we'll form our game logic. And the only other thing we want to do is we want to add a tag to this gap section. So we can go over to the tag section, add tag, and add a new tag, and we can call it score up. Cool. And then make sure you assign it to score up. And then all we need to do is we need to make sure this is at 0, is we can just drag this whole parent object here into the prefab section. And then we have our own, we can get rid of it now, and then whenever we drag it in, we have our own prefab sort of area that will give us a score, and we can run into these two enemies. We don't have any of the logic coded in yet, but this is how we'll be going forward with the prefabs. So we've created one prefab, but we actually need to create 2 more prefabs. And I'm pretty sure you guys will guess how we're going to do it. Let's just do it really quickly. Copy, paste, and we can paste it again. Let's open up a triangle. So we've got one at -2. Let's add this, make this one 0. Let's turn off this one, and turn off this one just so it looks, so we can see what's going on. And we need to make our gap at 2. So then, let's turn off our player as well. So then we have a situation where we have the two triangles on the left-hand side, and we have the cube here. So that's fantastic. We can call this triangles B, drag this in, done. Now we can get rid of this, and get rid of this. And we can do the same thing here. Turn it back on. We can go triangles at 2, triangle at 0, and we can make the gap -2. And then we can call it triangles C. Awesome. So then if we delete this, you'll be able to see if we drag this in, and then we drag this in, and then we drag this in. And make sure these are... Also, we've got to turn the playback on. We can press play, and the player can move through these sections. Oh, we need to make sure that all of the gaps, let's just go to gap is trigger, gap is trigger, and gap is trigger. Press play. And we can pass through, and everything works fine. Cool. So we got a basic scenario here. So let's just, I'll just drag this up. So we got A, B, C. Let's put this one at, say, let's put A at 20 on the Z. Let's put B at 40. And let's put C at 60. So if we press play, let's see what it looks like. Cool. So we should get a score there. We get a score there. And we get a score there unless we bump into them. So in the next episode, we'll be coding the functionality of these gaps and these triangles. What happens when you run into a gap? Well, we want the score to go up. So in the next episode, we'll be coding the logic or the functionality behind the prefabs that we just created. See you there. To create a score, all we're going to do is go over to the assets, go over to scripts, right click, create a new script called score, and we can drag this straight onto our player. So now we see the script is attached to the player. We can double click to open, and we can create a new public int score. Remember, integers are whole numbers, and because our score is going to be in whole numbers, we'll just use an integer. We don't need a start. And we can go inside of update and just write debug.log. The score is space. Make sure we go outside the speech quotes, plus, and then just pass in our score. Happy days. So all we need to do now is call the onTriggerEnter method, which is an inbuilt Unity method that just calls when we run into a trigger zone. So we can write void onTriggerEnter, pass it a collider, and we can call this other collider other, and then open curly brackets, close curly brackets, press space, and then we've got a collider working. So we can actually just write a debug.log here. Collider is working. And let's just see how that works. Let's go over to Unity and let's press play. Awesome. So if we go over to our console, we see the score is 0. Which got called 270 times because we have the update method calling it every single frame. And our score was at 0 and collider is working. So what happened there is when we went through the gap of this first object here, it triggered the onCollision enter. So we entered the collider of a gap. And because it's trigger, so it said, okay, on trigger enter, we enter the collider. Okay, let's call this function, but we want to actually know if it's the correct collider because we just don't want it to be calling all the time. So we can actually check for a tag. So we can say if other.gameObject.tag equals So when you put two equal signs, you're asking the question, does it equal? And one equal sign, you're assigning something. It equals this, for example. So we're saying if other.gamer.tag equals score up, then we want to do something. So if you remember, we have in our triangle, our gaps are tagged with the tag score up. Make sure you spell it exactly the same with the capitals exactly the same, like uppercase, lowercase. That's why I said to make it lowercase. And then we can say something as simple as score plus, which means the score will go up. Awesome. So let's check this out. Let's press play. Let's look at the console. Score is 0. Score is 1. Score is 2. Score is 3. Awesome. So now we have the logic behind our score system. Whenever our player bumps into a gap, it will add 1 to the score, and our score just keeps adding up. Fantastic. Okay, so the next step is to get our score to actually display on the screen. So we can go over to Window, and we can go to Package Manager, and your version of Udemy should have TextMesh Pro already installed. TextMesh Pro was another asset that was purchased by Udemy just because of how awesome it was, but it should already be installed. But if it's not, click under All, scroll down, find TextMesh Pro, and install it into your project. Cool. So what we want to do is we want to right click. We want to create in the hierarchy. We want to create UI, TextMesh Pro text. It's going to ask us to import TMP Essentials. Just click yes. It's going to import. And we don't need the extras. Quit out of that. And so we have our TextMesh Pro text, which is just up here. So you'll notice it's also created a canvas and an event system. We won't be touching these too much, but we're going to go straight to the TextMesh Pro text, and we want to change the text to, say, 35. And we can change its position up to here, and we can change the font size just to adjust a little bit more. If you look here, we can actually drag these out. So everything fits well. Awesome. And just fiddle around the settings until you get something that you like. Okay, so that's all good and fine. But if we want to use the font that we've actually imported that's part of the assets, or if you want to use your own font, what we need to do is we need to actually create a font asset. So TextMesh Pro doesn't actually use like text as we would imagine it. It actually creates this super high res version of the text and does this tricky cool stuff. So basically our text looks perfectly crisp and smooth. So what we need to do is we need to go to Window, and we want to go to TextMesh Pro, Font Asset Creator. We want to select our font, blocked, which should be there. Auto sizing, padding, everything is fine. Generate font atlas. So it's going to generate the font atlas. Cool. And then we can click save. Save as. And we can put this in our font and just as that, save. Now we can quit out of this, go back to our TextMesh Pro, and we can now select that from up here, which I think looks a little bit better. More suited to our game. So you can mess around with a few of the settings here. We can obviously change the color. We can do, some cool stuff, and you can mess around to see, to make it look how you like to look, and adjust some things and certain stylings to make it look how you want it to look. And so now when we press play, obviously nothing's happened because we haven't actually connected our script to the score here. So we'll do that right now really quickly. So if we go over to our player, we open up our score script. All we need to do is add a new namespace. So this will tell Udemy that we're using TextMesh Pro. So we say using TMP pro, just like that. And then we can create a new public text pro UGUI. I'm going to call this score UI. Awesome. And then inside of update, we can actually get rid of the debug.log now, and we can just write score UI dot text equals score. So we're actually saying the score UI text, so the score of this object equals this score, but we can't actually pass a number because a number isn't like text. It isn't a string. So we need to use a function called .toString. Done. And that should work absolutely fine. So if we go back over to Unity, we go to our player, we'll notice that on the score script, a new score UI element appears. We can drag in our text mesh pro text. We can also rename this to make it easier and just call it score. And our player has now the score, and now when we press play, it should update to 0. And then when we go through, 1, 2, 3. Awesome. So it's just as simple as that. So we haven't actually talked about what happens when we bump into one of the triangles. And we're going to leave that for a later episode because it'll work a lot easier if we do it when we're dealing with things like menus and the game over method, so we can do it all in one place. But right now we have a working score, and that's all that matters. See you in the next episode. So this is where the fun stuff really starts to begin. We're going to start talking about procedural level generation. What is procedural level generation? Procedural level generation is basically randomization, but within certain rule sets. So we can create a level, and we want that level to be created, but not at complete randomness. We want to set the certain rules that that level is created in. So for example, No Man's Sky builds planets under certain rule sets, or Minecraft builds worlds under certain rule sets, or games like Spelunky builds their 2D levels under certain rule sets. But how do they actually accomplish this? Well, to understand procedural level generation, let's look at a very, very simple example. Tetris. In Tetris, everyone understands how to play Tetris, I hope. You got to line up the lines horizontally, and then you get a point or whatever, or the thing goes down. But basically, the way the procedural level generation works in Tetris is you're given random shapes and you've got to get them to fit together. It isn't programmed what shapes will come out at what times. It's actually chosen at random. But the shapes aren't random. The shapes are actually selected from a group of different shapes that the creator has decided. Okay, we're going to have this pointy shape. We're going to have this T shape. We're going to have this straight, four line shape. And we're just going to have a bunch of different shapes, and we're going to choose out of these different shapes, and we're just going to procedurally generate them at random as the game is actually playing. So what this means is that the creator can play his own game and be surprised with the results. So this is actually a really fun way to make games. It can also be very frustrating because you can't predict what is going to happen. Not perfectly anyway. But how does this relate to our game? Well, our game has a level that goes on forever and ever and ever. We'll deal with this in a later episode, but we also have triangles that need to spawn, not at random, but kind of at random. They need to spawn at preset locations based on certain rules that we give the program. But they need to feel random. They need to feel like they're chosen at random, that the computer is making the choice, in which it actually is making that choice. So when our player goes along, he may run it into a prefab with two triangles on the left, and then he may run into a prefab with a gap in the middle, and then you may run into a prefab with another gap in the middle. And this is totally random, but it's within certain rule sets. The reason why procedural level generation could be so fun to play with is because you can adjust the smallest variables or the smallest things or add the smallest component, and it can totally give you totally crazy different results and different game feel, and your game will feel different. And if you're confident enough in programming, you could take this the next episode and add to it, and your game will feel completely different to everybody else's. That's what's awesome about procedural level generation. So now that you understand a little bit about what procedural level generation is, let's implement that into our game. So let's start a new script. Right-click, create, new, C# script, and I'm going to call this Object Spawner. Open that up in Visual Studio. Cool, and we want to create a couple of variables straight off the bat. First of all, we need to access our player. So we can create a public game object player. We've done this before. We also need to create a public game object. And here's where it gets crazy. We're going to build a array of game objects. So not just one game object. We want to create basically an array, or you can imagine it like a list or a grouping, but they're called arrays. And to do that, you just add open and close square brackets after the game object. And we want to call this triangle prefabs with the S. We do S at the end so that we know that it's an array. That's just for our own sake. Cool. So the only other variable we need is the location that the objects will be spawned at. And we can store this in a vector3. And because we don't need to access this vector3 inside the inspector, we can just leave it as private. So we can say private vector3 spawn obstacle position. Cool. I don't think we need start, so we can get rid of start. Get rid of that. First thing we want to do, we want to create a throwaway float called float distance to horizon. We're going to call it. And the horizon is just going to be an arbitrary amount of space between our player and how far we want the objects to spawn. So we're just imagining an horizon at this stage. And when our game is actually curved, it actually will be over the horizon. And that's going to equal a vector3.distance. And the distance we want to get is between the player.gameObject.transform.position and the spawn object position. Awesome. So now we have a variable that is just a float between our player and this spawn location. So what was the purpose of this variable? Well, we want to create a fixed distance between where the objects spawn. We don't want them to spawn with gaps that are too big between the triangles, and we don't want to between the triangle prefabs, and we don't want to spawn them too close together either. We want them to be pretty consistent. So what this can do is, because we know this value, we know the value between the player and the spawn object position, is we can say, well, if it gets to a certain length or it gets under a certain length, then we can spawn a new triangle. So then all we need to do is run an if statement. If distance to horizon is less than, say, 120, well, then what do we want to do? We want to spawn triangle. Now, this is going to, and we're going to do with capital. This is going to throw an error because we don't actually have this. We're trying to call this method, but we actually haven't created this method yet. So let's just create the method down here. So we go void spawn triangle. And you see now that it's fixed the error, but I suppose we want to actually say spawn triangles. Just so we understand that we're actually spawning the triangles prefab. This is just for our sake, so we understand our code a little bit better. And then all we want to do is we want to change the spawn obstacle position. I want equal to a new vector 3. Do we want to change it on the x-axis? No, so we'll leave it at 0. We don't want to change it on the y-axis, so we'll leave that at 0 as well. And then we want to change it on the z-axis by spawn object position, so that the z value of spawn object of position dot z plus a distance of, say, 30. So this will be the amount, the distance between the different triangles. So you can adjust this number 20 or 50 or whatever you find fits best. Awesome. So that's literally it. We've created the locations of where our triangles are going to spawn, but now we just need to spawn them. So the next line of code is where the magic happens. It's where we actually spawn the triangles. It's called instantiate inside of Unity, and Unity has an inbuilt method that helps us do this. It's really, really simple. All we need to do is write instantiate. Then we need to open parentheses. We need to tell it what we want to actually instantiate, and we want to instantiate one of the objects of the triangle prefab. So right now, why don't we just choose the very first triangle prefab? So we'll say triangle prefabs, open square bracket, open parentheses, and we'll just write 0. So the object of the set is 0 index of the array. And where do we want to instantiate it? Well, we want to instantiate it at spawn obstacle position. And how do we want this object to be rotated when it's placed in the scene? Well, if we want it to be exactly like we have set it in the prefabs, we just need to write quaternion, which is a very hard word to spell, quaternion.identity. Close the parentheses, end with the semicolon, and save that. Quaternion.identity is whatever the game object's default rotation is. So we choose what a game object we want to spawn or instantiate. We set the location, which we set up here, and then we say just spawn at the default rotation. Awesome. So let's go back over to Unity and set everything up. Let's create a new empty game object. We're going to call this scene manager, and I like to put a little underscore at the start there, and I like to drag it to the top. And I also like to zero everything out just to keep things neat. And we want to add the script object spawner. Awesome. It's asking for our player, so we can just drag our player in. It's asking for our triangles. So if we open up this tag, it's saying, well, we actually have 0 objects so far, so we can just change that to 3. And then we can go over to our prefabs. We can drag in triangles A, drag in triangles B, and we can drag in triangles C. Then we can take these 3 triangles and we can turn them off. And when we press play, ta-da! We have procedural level generation that will just keep on going forever. But there's a problem. As you can see, our game objects are spawning the very first game object over and over and over again. We'll deal with this problem in the next episode. Okay, so this is a pretty easy problem to solve. So we want to open up our scene manager script. Our object spawner script. And you'll notice here that we're instantiating a triangle prefab at the index of 0. So if we just change this to 1, save that. Let's go back to Unity, press play. All of a sudden, it's spawning element B. Well, we need an element of randomness in our game. Our game feels a little bit boring if it's just this the whole time, and you can see that they're instantiating, 120 clicks away from the player. So what we want to do is we need to actually randomize this number. So we could create a variable, I suppose, up here to say create a random number that's the length of a throwaway variable, here, or we could create a random number up here and create a random function. But it's actually pretty easy to just create a random range inside of the actual instantiate method here. So it's actually asking for what location index we need. And instead of writing 1 or 0 or 3, or I'll show you what happens. If we do 5, we'll go over to Unity and we'll press play. And it will just not do anything. The game's actually playing. I'm not sure if you can see. Game's playing. You'll see over in our console, array index is out of range. So I was basically saying hey, if we don't have 5 game objects here, we only have 3. So what we can actually do is we can go, instead of writing 0, 1, 2, or 3, or 5, or whatever, we can actually create the random method or function inside of here. So how do we do that? It's pretty easy. So instead of writing 0, 1, or 2, or 3, or whatever, we can actually just write random dot range, and then we can open another set of parentheses, and the range will be from 0 to, now we could write 3 up here because we know there's only 3 prefabs, but what happens if we lose one of the prefabs, or if we add more in the future? A better way to do it, and better coding practices, is to just write triangles prefabs dot length. So whatever the length is, that's what it'll be set to. And then close parentheses again. So if you look at this, 1 open parentheses, 1 open parentheses, close parentheses, close parentheses. And then obviously close parentheses here, and you can see it highlights. Cool. So if your code looks like this, everything should be fine. So now it's choosing a random number between 0 and the length of how many triangles we have. Awesome. Happy days. So let's see what that looks like in the real game. Press play. Awesome. So now we have actual procedural generation. Our game is a bit slow and boring. It may be simple, but it is procedural level generation. So every time we play the game, it'll be different. So we press play. It's got 2 in the middle there. Press play again. Awesome. Press play again. Awesome. So you could create more prefabs if you wanted and add more to this, add more variety. But for the sake of the tutorial, I'm just going to leave it at 3. But feel free to add your own prefabs and add more of them and do everything that we've done already, and your game will be different and feel different. And also you can adjust the numbers inside here. You can adjust this number, or if you want it to the horizon be further away, you can adjust this number. But yeah, awesome. So right now, if we press play, we've actually got a working game. Our game is pretty boring and our game is pretty basic, but this is at prototype level of gameplay. We can play the game. We already know it's too slow, but we can see that the game is actually working and we can get a feel for what the game is actually like. So we've actually finished the game portion of our tutorial series, and that's really awesome. So the next portion of this series is the polish. This is where we turn this game from looking like this into the finished and final product. We iron out some code, we add some saving, we add the world curvature shader script, and we do some really awesome things to take our game to the next level. We polish it up, ready for release. So join us in the next section where we take this game to the very next level. Okay, so let's start polishing this game. So right now when we press play, you'll notice that the game is really, really, really fast. That was a joke. It's really slow and boring. So first thing we want to do probably is speed up the player. I think it's at 500. Let's try 1500. Press play. Oh, yep. That feels a little bit better. I'm actually feeling like there's some sort of a challenge. Cool. And because we like that, let's open up the script and change the default to 1500. Just so it doesn't stop up on us later on if we adjust something. Cool. So the next thing we want to do is right now we've got a pretty boring plain ground and we want to kind of change that. So to do that, let's turn off our ground and let's turn off our water just for the time being. And let's drag in our, let's go to models and let's drag in our ground. Awesome. Okay, so right now it's just a little bit high, so let's just reduce that by -0.5. Well, that looks perfect. And let's call this just ground. Cool, and let's just see what that looks like. We'll press play. Oh, yep, things are looking tasty. So you can see the little edges here make it look a little bit, like you can tell your player is moving a little bit better. And now we want to implement our shader. So our shader is what's going to make the world look warped. So what a shader does is it doesn't actually affect anything in the, doesn't affect real world coordinates per se. It more tells the compiler how things are going to appear on the screen. We aren't going to go into how shaders are coded in this tutorial because they're a lot more complex and not really a thing that beginners can really touch on. But it is something that really kicks up the look of your game to a whole new level. So luckily we've got a shader script already here called Curved World. So if we just first of all go over to our model, click on our ground, open that up, you'll see we have 3 different textures that are already imported here. So let's click on our ground first, and we're going to say extract materials. And it's going to ask us where to extract these materials. We want to choose the material folder. Select that folder. Awesome. So it's extracted those materials. Let's go over to our materials, and we'll see we've got grass matte, sand matte, and water matte. So we probably don't need these other ones, grass and water. And delete them. They're the old ones. So we've got water matte, sand matte, and grass matte. And right now they're using the shader standard. If we change this, we could change it to something like that, which looks horrible. We're going to leave it as standard. And we're going to, what we're going to do is we're going to grab the water, we're going to grab the grass material, and we're going to grab the sand material. I'm going to change them all to curved shader. Awesome. So if we press play now, nothing happens. And the reason nothing happens is because we need to actually pass in some variables to the shader and say, well, how much we want this shader to curve our actual world. So to do that, let's go over to our scripts folder. I'm going to create a new script called app initialize. So this script will handle things like frame rates and just like little settings that we may have. And so it's just common practice to call it app initialize. And let's just drag that straight away onto the scene manager. So our scene manager has that script, and let's open up that script. So normally inside scripts, void start is the first method that is called straight away when the script loads. But there's actually a method that is called right before start. So if you want something done before start, you can use void awake. So we'll be using that. So void awake. So if you want something to happen before start, this is where you'd put it. Make sure it's capitalized and everything. Looks exactly like that. And then we just need to write shader dot set global float, open parentheses, open speech marks, underscore curvature, comma, and we're going to set it at 2.0f. Awesome. And the next line we need to write is shader dot set global float underscore trimming (0.1f). So these are settings that I've tested out that work the best, but feel free to adjust these numbers to adjust the look and the curvature of your game. You can also create variables up here that you could, like you could have curvature and you could have trimming. You create these variables here and you can make them public, and then you could change the variables for these numbers here. And then as we've done before, you can then adjust them inside of the editor, and you could see things adjust in real time when you're playing the game if you wanted to test out things. But I found these two numbers to work pretty good. So if we press play now, you'll notice straight away we'll get some crazy looking graphics. Ready? Press play. Okay, so first of all, the world curves, which is what we want, and these don't curve. Okay. So first things first, let's grab the camera and let's just drop the rotation down to about there. Don't worry, we'll fix up this ugliness up here in a second. So let's just drop it to, say, 24, whatever looks good on your game. And right now, if I press play, I want to show you something that's pretty cool. So this is the edge of the material. Okay, now I want to point out something. Hang on a sec. This doesn't look right. The further we go back, the further this rolls off. And the edge here is actually at the level 0, where our player is at 0 and this is on the ground, so it's at 0. So what's actually going on here? Well, what's going on is this is not actually moving the vertices, it's not actually moving the model and changing the model's direction. It's just appearing that way, where the shader is basically tricking the graphics to render it in a certain way, if that makes sense. If that's an easy way to understand it, it's adjusting how it appears on the screen, even though we're not actually going over a hump, if that makes sense. We're not going around a world. So what we can do, so what's happening here is there's a little bit of a problem though, because right now these are hovering up in the air, and that doesn't really make sense. Well, actually, no, it does actually make sense. And the reason it makes sense is if we go into our materials, we'll notice our triangle has the standard shader, and the standard shader isn't being affected by anything else. So if we just change this shader to curve world, all of a sudden they plop right where they need to be. So if we unclick play, and you'll see that things are just the way they're supposed to be. Now, our player is still at 0 and all these items are still at their height of 0, but it appears as if they're not. That's the awesome power of shaders. So the last thing we want to do to make our game look a little bit better is we want to fix this ugly background. So what we can do in materials is we can create a new material here, create new material. And I'm going to call this 2D skybox. And we're going to set the skybox to a mobile skybox. And we're going to set our Z texture to our textured skybox. We're going to go to our main camera and we're going to add a skybox. And then we're going to just drag in our custom skybox. And you'll see our background is fixed up. Well, it looks better anyway, but it's still not perfect. We need to adjust our offset a little bit. So if we just drag this up and down, you can just get something that you think looks good. 4 maybe, 5, 6, 5. That looks good to me. 0.05. So now if we play the game, we have a curved world and things look pretty cool. Might need to adjust the camera a little bit. Just give it a little bit more room. So maybe 23. Press play. Cool. So you can adjust things to your liking and you can muck around with some of the settings. You can even drag the camera up. And I'll see you in the next episode where we will focus on, I'm going to leave that as 5. I'll see you in the next episode where we will focus on making the world go forward infinitely. So I'll see you there. Okay, so you may be thinking the next part is actually pretty hard, but actually it's really, really easy because of the way we've set up our game. So remember, everything is on a flat plane. Everything is at the coordinate of 0 in the y-axis, and our player is actually is positioned in the y position because it never needs to move up or down, although it appears as moving around an Earth, around a planet. So what we need to do, we have our ground here, which has our ground and our water. We actually need to create a new object called, I'm going to call this planet. Let's set its coordinates to 0, 0, 0. And then let's just grab the ground model here and put it under the planet. And then all we need to do is we need to find the end of the planet. So right down here. And we need to create a highlight here, and we need to create a new 3D, new empty. And we're going to call this trigger zone. And we're going to add a box collider to this. And we're going to make it is trigger. And we're going to, so right now our planet's coordinates should be at 0, 0, 0. Our ground should be at 0, negative 0.5 and 0. And our trigger zone needs to be basically at the end of this planet area here. So if we just drag this forward, we can see that it's at about 100. So if we just spin this around, we'll see that, yeah, it's pretty much at 100. So if we just make this 100, should be perfectly on the edge there. And then we can make this scale, say, 5. Just make sure it's wide enough. Actually, let's make that 10. And let's make it, 5 on the y-axis as well. Cool. So that definitely covers us. So when our player goes through this trigger, we need to do something. And what we need to do is we need to create a script, add it to this method, and then we need to add some instructions in that method. So let's just do that. So let's go over to our script folder. Let's right click, create C# script, and we'll call this level gen. Let's drag this onto the trigger zone. So our trigger zone should have the level generator script, the is trigger box collider, and let's open up level gen. Okay, so inside of our level generator script, we can actually just delete the void start and the void update. We don't actually need them. Okay, so the first thing we need is a onTrigger enter method. So we can actually go over to our score script and just copy this one here because we've already written it out. Dump it in here. Void onTrigger enter. Awesome. Collider other. Cool. We don't need this. And we don't need the if statement in here either because we only have one thing that's going to be colliding. And then we're going to need to call a method. But the type of method that we're going to be calling is not actually a method, but an IEnumerator. So it's the same as the method, but what it lets us do, it's a coroutine. And what that means is what it lets us do is it lets us wait for a certain amount of time before we perform a certain action. Don't get too caught up in the terminology here because we won't use these too much. But just know that we need to first create a IEnumerator, which is like a void, but it's not a void. So we do that by creating IEnumerator. We're going to call it transfer. And inside an IEnumerator, it needs to return something. And so what we need to do is we could write return null. You'll return null, but we're not going to do that. We want it actually to wait for 1 second. So we're going to say yield, return new, wait 4 seconds. And then it's going to ask us how many seconds, and we just say 1. Cool. So now it's going to wait 1 second before it performs the next line of code. And all we need to do to call this transfer coroutine or IEnumerator is to start a coroutine. So start coroutine. My spelling is atrocious. And then we can just open parentheses, open speech marks, and write transfer. So that's a little bit overwhelming. I understand that. It's because it's different terminology and different ways of calling things how we normally would, but this will work just fine. And so now we're just going to write debug.log, hit the trigger zone after 1 second. And let's close that out with a semicolon, copy this. Let's dump it in here just to make sure everything's working. Delete that, and we can go back to Unity and press play. So if we press play, alright, if we go over to our console, hit the trigger zone after 1 second. Awesome. So we know that this is working perfectly well, so we can delete these two debug.logs. And the only other thing we need to do to get the level moving forward continuously is we just need to wait for 1 second. And the reason we need to do that is just so we have enough time for the player to move through the trigger and for this part of the level to be behind the camera. So that's why we wait 1 second. And then all we need to do is move the level forward by that certain amount. So it's actually quite easy. So all we need to do is write game object dot transform dot parent dot position equals new vector 3, and our new vector 3 just needs to be 0, not changing the x-axis, 0, not changing the y-axis, and then game object dot transform dot position dot z plus we need to have a certain amount, and we need to work out what that is. Let's just say 100 for now, but we need to actually work that out. Add a semicolon at the end there. So the reason we use GameObject.transform.parent.position is because we actually need to get the position of the parent game object. So if we remember, our trigger zone is here, but we don't need to move just the trigger zone forward. We need to move the parent. So we need to actually get the parent object, which is this planet A. So that's the reason we use transform.parent.position. Cool. So now we've got our planet here. Let's just copy this and paste it. And let's just drag this one forward right until we hit the right spot. So if we can see here, we got 200. So we know the value that this needs to move forward because this planet is at 0. We know the value that this needs to move forward is by 200. So let's go back into our script and let's change this to 200. And let's name this planet underscore B. And let's name this planet underscore A. And let's just press play and see what happens. Okay, so we're going forward. And it appears that the level just continues forever. So what's actually happening here? So let's just have a quick look. If we go to our scene manager script and we turn off object spawner, so we've got nothing in our way, and we press play, we can actually go to the player and you'll see that what's actually happening is as the player passes certain spots, it's deleting the world behind the player and sending it 200 clicks forward, if that makes sense. But from the player's perspective, the player that's actually playing the game, you see our shader is stuffing up our view there a little bit. That's okay. It just looks like the world is going on and on and on and on forever because it's lining up seamlessly. We know exactly where things are lining up, and the world will just continue doing this forever, or until the phone breaks or something like that. So go back to the scene manager. We turn back on object spawner. So yeah, this is basically simple procedural level generation. But the only problem we have now is now, if we pause it, we have a bunch of different triangles here, and eventually they'll add up in our memory, and things will get really messy and really slow, and it'll use a lot of data. So what we want to do in the next episode is work out how we're going to clean up the stuff that's behind the player. So see you there. Okay, so to clean up the triangles after they've been spawned, all we need to do is we can go to our scripts folder, create a new script. Let's call this script destroy. Yeah, cool. So what we would normally do is we would normally find the position. We would normally create a public variable for the game object position of our player, and then we would just drag that in. But because our items are being instantiated from prefabs, these different prefabs here, we can't actually do that because we'd have to drag them in, and so we're actually going to approach this in a different way. We're going to say private game object player, and then inside of our start method, we just want to assign the player there, and we can do that easily by saying player equals game object dot find game object with tag. Make sure it's not game objects, but game object. Open parentheses, open speech quotes, and capital P player. Awesome. So that will find our player. And let's go back over to Unity. Let's go to our player. And let's make sure the player is tagged with the tag player. That's definitely important. So now the Navigame knows that the player is our player, if that makes sense, because we've tagged it. And back over to the script. And then all we need to do is we need to say, well, hey, when something is behind the player by a certain amount, we just need to delete that thing. So we can just run an if statement inside of update. If game object dot transform dot position dot z is less than player dot transform dot position dot z minus 15, so that gives us a little bit of room. Open close parentheses, open curly braces, and then all we want to do is say destroy game object Cool. So that will just destroy this game object. Whatever script this is attached to, whatever game object this script is attached to, it will destroy that game object when the this game object gets below 15 in the z-axis of behind the player. So 15 spaces behind the player in the z-axis. I hope that makes sense. So all we need to do now is we can grab our 3 prefabs here and we can add the script destroyer and we can press play and hopefully everything works out. Let's just have a look. So you look to your left here and things should be being deleted. And they are. Things are working great. So let's just check that out in the scene view. Let's just go to our player. Things look a little bit wacky because of the further we move away, obviously our shader works differently, but if we press play, just watch this one, and it's deleted. Cool. Awesome. So that seems to be working fine. So with a simple script, we have just asked the question, hey, are you 15 spaces behind the player? And if so, just destroy that game object. And that's it. You can use for any object that will be behind the player. And because our objects are pretty simple and because we're not deleting them not destroying them massively, like huge amounts, we're not destroying mass amounts of objects, this is actually a really fun call to work perfectly on mobile devices. It's not going to be too much of a drama and it's a really simple solution. Cool. So how we're going to approach this is in this lesson, we're going to set up the basic menus system. And the next lesson, we're going to start coding in the actual functionality of it. So this lesson will be more just dragging and dropping, setting things up, how you like them, and I'll explain some core concepts. So let's first start off by dragging canvas right up to the top, just so it's easier. And we're going to create 3 menu items. So create empty, create empty, and create empty. The first empty will be in game. So this will be the menu that will be displayed in game. The second one will be in menu. So this will be inside the menu. And this one will be game over menu, UI. And it's good to put UI at the end of it, just so we understand it's UI. Cool. So our score is actually part of the in-game UI. So let's just first check these are all at 0, 0 with width for all good, all good. So we can just drag our score into in-game UI. So for example, if we wanted to turn off the score, we could just press this and turn it off. And we can do that through code, which is what we'll be doing in the next episode. So if we just go up to our score, and we can actually put it on 2D to make things easier. So let's turn off all these other menus for now, and let's just focus on the in-game UI. So the in-game UI, the only other things we'll need when we're playing the game is a pause button. So we can right-click on here and click Create New UI button, and then we see the button pop down here. We can call this Pause button. And then we need to go down to our sprites folder. We need to click everything beside the skybox, highlight that, and we want to change it to a sprite 2D UI. All this should be fine. Press apply. Cool. And then when we go back to our pause button, we can change the sprite to our pause button. We can click preserve aspect, and then we can change the width to 150 and the height to 150, and then we have a pretty cool looking play button there. We can actually pause button, and we can actually get rid of the text because we don't need that. And click this, and then we can just change its position. So change that to a spot that you would like. And then I'm just going to drop the opacity a little bit. Cool. So it blends in nicely with the screen. Awesome. So right now it doesn't do anything, but that's fine because we're just setting up the menu at this stage. Cool. So in the next part, we are going to deal with setting up these two menu items. And then after that, we will hopefully be able to jump into coding some functionality. See you there. Cool. So it's time to add some simple sound effects to our game. This is also very easy. So let's actually get rid of our ground because we don't need that anymore. And our water, the two things that we took off, not these guys, but the two objects we turned off in the earlier episode. And we can save. And then all we need to do is go to our player. And we need to add a component to our player called audio source. And then we can go inside of our audio and we can actually go back, click back on our player, and we can actually drag our theme song to our audio clip section, and we can press play. Cool, so that's working just fine. Then we can open up our player script and we can create two new variables, public, audio clip, and we're going to call this score up, and another one, public, audio clip, damage. Cool, so then we need another on-trigger enter function. So if we go over to score, we can actually highlight this again, and we can go back to player, and we can go underneath the update, dump that in there. We don't need this. And if other.game.tag equals score up, that's actually exactly what we need. So we can just write our audio code in there. So we can say get component. So once again, this is getting the audio source component, audio source, just like we did in earlier episodes. And we can say audio source dot play one shot. And we can say what clip do we want to play. We want to play score up. And just at 1.0 F volume. Cool. And let's just copy this. Copy. And we want to change this from if other.game.tag equals triangle. We want to play the damage sound effect. So let's go back over to Unity. First of all, let's make sure our prefabs, let's make sure our triangles actually are tagged with triangle. Yep, they are tagged with triangle. And the gaps are tagged with score up. Okay, everything is going fine so far. And then we can go over to our player and we can assign our score up and our damage variables, and they'll just be in SFX. So go back to player and go down. So score up, score +1, and damage as damage. Cool. Now this won't work how we think it's going to work just yet, because on our prefabs have a mesh collider. And this is actually a mistake because our gap will work fine and we can actually test that because it's a trigger, but these are not triggers. And in fact, we probably don't need a mesh collider because they're such simple shapes anyway. So to fix our problem, we just need to click on all the triangles within these prefabs. We can remove the mesh collider, and add a box collider. Because it's such a simple shape, they should fit perfectly, and we can just test it by dragging it in. And you'll see here that the box collider is pretty much perfectly around both objects. That is exactly what we want. And do that for the other two. Let's change the prefabs, remove the mesh collider, add a box collider. And make sure we click is trigger. That's the other thing that we need to do. And the third one now. Remove mesh collider, add box collider. Tick is trigger. Cool. First of all, let's remove the triangles. Cool. And just for the sake of our own sanity, let's go and mute the audio source. We know it's working now and we don't need to hear it every single time we play the game. So let's just mute that. Cool. So things seem to be working absolutely perfectly. We have our theme song. We have a noise every time the score goes up. And when we run into something, we get the big thud as well. Of course, we just pass through the game objects now, and that is fine because what we're going to do is we're going to actually write some code for our game for what will happen when we actually bump into one of these triangles. So don't worry, we'll fix this in a later episode, and we'll see you there. Cool, so now we're going to be dealing with the in-menu UI instead of the in-game UI. So this will be like our main menu, but it'll also be our pause menu. They'll be both be the same thing. So first thing I'm going to do is turn off our in-game UI because we won't be seeing that. And then under in-menu UI, we want to turn that on. And then we want to right-click and we want to create a new UI panel. And we can just drag this right up. Awesome. So that covers our main area. We can change the color if we want a little bit. So we can have like a bluey color or something. Just choose something that you enjoy. So we want to create our play button. So we can just right click, create new UI button. Same deal. We don't need the text. Call this play button. You can change the sprite to a play button, preserve aspect, and then we can change the height and the width to 300 by 300 or whatever you think suits. I'm going to bring it down a little bit just to cover up our player. The next thing we want to do is create a new empty. I'm going to call this logo. And then underneath logo, we're going to create another UI. We're going to get a UI image. And that image is going to be our balloon beach title here. Once again, choose something that suits you. Drag this up. Call this title. Then I want to create a new image. I'm going to choose the game title logo, ball. Change it by 250 to 250 and also bring this to the right location. I'm going to call this left ball and I'm going to copy and paste right ball. Cool. And I'm just going to drag the title underneath. So kind of there in the background, and then just fiddle around until you get something that you think looks good. Cool. So that's the in-menu UI. Obviously nothing is working just yet, but let's just turn off the in-menu UI and let's go to our game over menu UI. So first thing we want to do is we can actually copy this panel. Awesome, just drag it into there. You can obviously change this to be something else if you want something else to, like a different color, like we could make it like a red color or something. But I'm just going to leave it as is. Next thing we want to add is a button, and this will be to restart our game. So obviously, because it's going to be called a restart button. We can get rid of the text, because obviously we don't need that. Let's change the sprite to the restart button. Let's change the preserve aspect. I'm going to change this to 300 and 300, just like our play button. And then I'm going to drag it down just a little bit just to cover up our character as well. Once again, this is all personal preference. Do whatever you think looks good. Next thing is our heart. Right click, UI, button. So I'm going to call this heart and then in brackets add. Oh, show add. Suppose that's a good way of saying it. We don't need the text. You can obviously change the sprite to the heart. We can preserve aspect ratio and change the width to 150 by 150. Choose the position that you would like it to be. Cool. The other thing we need is our crown to show our high score. We still need to code the functionality for that, but that is fine. So the first thing we need to do is add another image. This image will be the crown. So I find that 438 by 290 looks pretty good. And change the position. Call this crown image. Next thing we want to do is add some text. So we're going to have some Text Mesh Pro text. I'm going to call this high score. You know the drill by now. Let's put in a number, 458, or whatever you want to name it. It's line above the center. Let's change the font. Let's change the size. Bring its position up. Okay, so now we have the basic menus set up. Now, it doesn't look crash hot, but all the items that we'll need are there. And in later episodes, we'll be coding the functionality and editing the animations. So now I'm just going to make some final adjustments to really make this menu system look better. This is all personal preference, so just choose whatever you think looks good and run with that. Cool, so I'm pretty happy with the in-game UI. I'm pretty happy with the in-menu UI now. I think that looks much better. And I'm pretty happy with the game over menu UI. Got a bit of a red tinge there. And I think everything is a bit more proportional and looks a little bit better. Cool, in the next episode, let's start coding the functionality. Okay, to start coding the functionality, let's open up our scripts folder and open up app initialize. Okay, so I'm just going to neaten a few things up here. We'll be doing a lot of work in this script in the next few episodes. So I just want to make sure that everything is set up pretty nicely. First thing we can do is we can actually write in awake application dot target frame rate, and we can just equal that to 60. That will mean that it will target 60 frames per second, so our game will look smooth on all devices. Then we can set a few variables. So these will be our menus, I suppose you can say. So public game object in menu UI, public game object in game UI, and public game object game over UI. So another variable we'll need is a reference to our player. So we can write public game object player. So now we can access our player. And we want to actually, the first thing we want to do is when we start the game, we don't want to start and just immediately start playing a game. We want to start in the menu. So the first thing we want to do is actually stop the player from moving. So we do that by just saying player dot get component rigid body dot constraints equals rigid body constraints dot freeze position. Then all we want to do is tell the game which items, which menus we want to have on and which menus we want to have off. And the first thing we want to do is we want to turn our in menu UI on. So we do that by saying in menu UI dot game object dot set active, and then we can just put inside parentheses true. So what that's doing is that is making sure that in menu UI is ticked on like that. That's what that set active represents. And the only other thing we want to do, and this is just for having clean code, is we want to turn the other two, make sure the other two are turned off. So we can say in game UI dot game object dot set active false. Close the semicolon, obviously. We can copy this, dump it underneath, and we can say game over UI. But game object set active equals false. So now if we go back to our game and we go to our scene manager, you see that we can fill in these 3 spots. So we can fill in the player. We can fill in game over UI, in menu UI, and in-game UI. Cool. So let's press play and see what happens. Awesome. So now what happens is all the other menus turn off and this menu turns on. Fantastic. That's exactly what we want. But now when we press play, well, our game doesn't do anything. We can, I suppose we move left and right if we use the control sticks, or the keyboard, but our game doesn't actually do anything. And when we press the play button, nothing actually happens. So we'll tackle this problem in the next episode. Okay, so to get our game playable again, so that when we press this play button, the game actually starts, let's go back into our app initialize script, and we need to create a new method. And this will, it's going to be a coroutine actually, but this method or coroutine is going to do everything that needs to happen when our game needs to start. So we don't actually need update, so we can get rid of update, and we can write enumerator start game. Cool. So this one actually, you see we've got an error already because our enumerators need to return something. And what we can normally do is we could like get it to wait for a few seconds and stuff, but we don't want it to wait every single time we play the game. We want to only, when we press play after we've died, we want to maybe wait for a second. But when we press play when we first started playing the game, we don't want it to actually like wait for a second. We just want to start playing the game, if that makes sense. So what we need to do is we need to have we can have a local variable. Now we haven't done this yet inside of this project. So if you're a little bit confused by it, that's fine. I think this is the only instance that we'll actually use this. But all we need to do is inside of here, we can pass some arguments that need to be called when start game is called. And the argument needs to be that we're just going to make the variable that you're going to need to put in for the argument. We're just going to make it a float, and we're just going to call this wait time. No semicolon there. And then we can just say yield return new wait for seconds. Whoop. And normally we would just put a number in here, but instead of putting a number in, we can just actually put in wait time, which is this float here. Now, why is this important? Why have we done it like this? Well, it means that when we actually call this coroutine, we can call it in such a way where we can actually designate how long it needs to wait for, whether that's 0 seconds or whether that's 1 second or 10 seconds or whatever. And we'll be using this method for 2 different purposes. For purposes when we end on a game over screen and we want to start again, or for purposes when we just start the game. So the other things that we want to do inside of start game are change all of these. So we'll copy all these, paste them in there, and we only want the in-game UI to be on. So the other 2 will be false, obviously. So make these false and make this true. Cool. We probably want this yield statement underneath all of these instructions here. And then underneath underneath this yield, we just want to set the player's motion back to whatever it originally was. So we can just grab this, copy this line of code, dump it in here. And we can say rigidbody.constraints.none. So now it's turned off all the constraints, and the only constraint we do actually want on is the Y, so we can go back, dump that in there again, and say freeze position Y. Cool. So let's just turn them all off and then turn the Y freezing back on. Fantastic. So you may be thinking, great, we got this well, not really long, but we got this big method here that kind of does everything that you'd expect it to do. But how do we actually call this method from inside the game when we actually press the play button? So if we press play now, you'll see that nothing happens. Well, we actually need to create a method that the play button can use. So how we do that, we need to create a new method called public. And it's important to say public so we can access it inside the inspector. Void play button. Cool. So later on, we'll add some more function. We'll add some if statements inside the play button to do the wait time functionality. But for now, all we need to do is write start coroutine. open parentheses, start game, which is the name of the coroutine, open parentheses again, and now it's asking, you can see here it's asking for our wait time, and we're just going to say 0.0f, which is 0.0 seconds, and then we're just going to close it off with a semicolon. Awesome, so let's test this out. So if we go over to our game, we can go inside of the in-menu UI, we can turn it on just because we're working on it, and we can go to our play button, and you'll see here it has a method called onClick. Well, we can actually press the add to list, we can choose the scene manager, drag it into that selection there, and then we can actually access functions that are on that script. So if we go click on this no functions, we can go down to app initialize, which is one of the scripts that's on the scene manager object, and we can go to play button. So what that'll mean is when we click this button, whether it's a touch screen or we're clicking on it with our mouse, it'll run the play button method on the app initialize script. And when we go over to our app initialize script and we see our play button, it calls the start game coroutine. And the start game coroutine changes all our menus, waits for however long it needs to wait, which at the moment is no amount of time, and then puts the rigid body constraints back to in-game functionality. So that should be pretty easy to understand. I hope everyone's following along. But if we press play now and see what happens. If we press play, awesome. So the game starts, and that worked great. We start it again, press play. Once again, I can press the play button, the game starts playing, and everyone is happy. Awesome. So in the next episode, we'll start dealing with pause menus and things like that, and continue on with this menu functionality. Okay, so let's add some pause functionality. This is actually pretty easy. So if we turn off our in-menu UI, and let's turn on our in-game UI, you'll see we have a button up here, play button, and we just need to have an on-click method that we can call that will obviously freeze the position and things like that. So if we go back over to our script, and we've got our public void play button, underneath that we can say public void pause game. Then we just need this set of bad boys. And then we can just copy this line of code, dump it in there as well. And then all we need to do is go over to our pause button, add a new on-click event, drag in our scene manager, done this in the last episode, go to app initialize, pause game. Cool, so if we press play, game will start, and we can pause it. Awesome. So say that we're playing the game here and we press pause right here. Well, when we actually press play, we're going to run straight into this this triangle, and we don't actually want that to happen. We want to give our player maybe a second to reposition themselves before they get slammed into this triangle. See if we press play now, there's nothing we could do. We would have gone straight into that triangle. So we want to give people a little bit of a warning after they've actually started the game and they've paused the game. So how do we do that? Well, let's go back over to our app initialize script. Let's create another variable called public, and this one will be a bool, and it's just going to be called has game started, and it's going to equal false. It's going to just default to false. Great. In fact, we can make this private. Doesn't need to be public, just so we keep the inspector neat. And then this is where we do that tricky if statement stuff that I was talking about before. So inside of our play button, we just want to have an if statement, right? And we want to say if has game started equals true. Remember, 2 equals asks the question. Then we want to start coroutine, but we want to actually wait for maybe 1 second. But if the game hasn't started, well, we want to say else. So if the game hasn't started, if the bool hasn't started equals false, then we want to just start with 0 seconds delay. Does that make sense? So if the game has started equals true, then we wait 1 second. But if the game hasn't started, we equal 0. Well, we haven't actually set this to true. So where do we set this to true? Well, it would make sense to put it inside the pause game method. So when we pause the game, that's when we say, okay, the game has started now. So first thing we want to do, well, probably the second thing we want to do is say has game started equals true. Cool. So let's test it out and see how it works. If we press play and we press play, everything's going well. It started instantly. Cool. And then let's press the pause button. And then we'll press the play button. Awesome. So it gives us a 1 little second amount of time to understand where we've got to go and what we've got to do. Press play, waits 1 second, bam, back into it. But if we start from the start, it just starts. Awesome. So that is working exactly how we want it to work. And now we have a functioning play button and a functioning pause button. And the next thing we need to do is work on what happens when you run into a triangle. Well, we know what needs to happen. We need to turn on this in-game over menu UI. So let's work on that in the next episode. Okay, so let's start working on the game over menu popping up. So it's also pretty simple. Open up the app initialize script, and we're going to create a new public void game over. And we can basically copy everything from the pause menu. But obviously this will be false because we don't want the in menu UI and to be on. We want the game over UI to be on. So the other thing that we want to do is if we look at our game, we have inside the in-game, the game over menu UI, we have a heart, which is a show ad button. So we need to create a method for when someone clicks on this button. When someone clicks on this, we want to show an ad and then give them an extra life. So we need to create that method first, and then in a later episode, we'll actually deal with the functionality of creating the ad system. But for now, let's just create a new public void show ad. And inside of show ad, we'll just write a comment, fix later, because this is something that we will need to fix later. But just so we can understand how things are going, we can just copy this start coroutine here. Awesome. So if we go back over to Unity and we go to the heart show ad, we can add an on-click functionality. We can drag over the scene manager. We can add a app initialize show ad. So when we actually fix this game later on, when we actually implement the show ad code, we will actually have another bool in here that will basically say, well, have we seen the ad before? And it's like, well, no, if we haven't seen the ad before, then we're allowed to press the button. Otherwise, we're not allowed to press the button. But right now, just for testing purposes, we're just going to put this in here. Fantastic. So we've got our game over working and we've got our show ad working. But how does void game over get called? The player needs to run into something and then that's when we need to call the method. So how do we do that? Because the app initialize script isn't connected to the player at all. Okay. So this is where we do some magic. We're going to go over to our player script. And you'll see we've got this audio source, if we run into a triangle, this happens here. Well, we can actually call a method on our app initialize script, and we can actually call the game over method because it's public. But how do we do that? Well, first we need to create a reference inside the player class to our script. So just at the top here, we can say public game object scene manager. And then underneath this play one-shot audio source inside triangle, we can just call the game over method from there. So we can actually say scene manager dot get component app initialize open parentheses close parentheses dot game over open parentheses close parentheses done. So now when we run into a triangle, it's going to call a game over method. It's going to move over to the app initialize script. It's going to call this method here. And that method, first of all, it makes the player stop its position. Great. It says game has started equals true. Great. And it pops up the game over UI. It says that active. So that menu pops up. Awesome. So then we have the option to restart the game and we have the option to show ad. So we've done the show ad functionality, but we also need the option to restart the game. So to do that, we just need to create another public void restart game. And this one's going to be a little bit trickier because basically we need to start with a new namespace because we're dealing with scenes now. We just need to write using Unity engine dot scene management. Cool. So then what this does is it gives us more functionality inside of our code here. And underneath restart game, we can just load the same scene that we're actually in. So right now, if we go to File, Build Settings, we'll see that we already have a scene in the build. If you don't, just click Add Open Scene. And you'll see that its index is 0. So that's the index for our scene. So we just remember that it's 0. If we go back to the code, we can just, when we press the restart button, we can just simply type scene manager dot load scene 0. Done. And just a note here, loads whatever scene is at index 0 in build settings. So let's go back over to Unity and let's get this functionality working. So let's go to our heart first. We've got app initialize show ad. Yep, that's all good. Let's go to our restart button. Let's add an on-click event. Let's drag in our scene manager. Let's go to app initialize and we want to restart the game. Cool. Let's press play. Correct menu pops up. Hurrah. Okay, and we've got an error. The error, let's look. So if we go over to the console, we'll see unassigned reference exception. The variable scene manager of player is not assigned. Okay, so let's go over to our player. We haven't assigned our scene manager. It says none down here. So let's make sure we remember to drag that over. Let's try again. Press play. The correct menu pops up. Press play. Bam. Okay. Now we can press this button. It waits for a second. Awesome. We can press that button again because we've obviously got unlimited lives at this stage. And it works just how we'd expect it to work. And if we die and we can press the restart button, it reloads the game. Awesome. So that is working just how we'd expect it to work. Fantastic. See you in the next episode. Alrighty, so what we want to do now is we want to adjust our high score, which is what will appear when we die or when we have the chance to use Unity ads. So, the way we want to do that though is we need to actually be able to save and load data. So this is actually a pretty exciting episode. So right now when we press play, and we press the play button and we die, the score is, well, it's at 458. This is not ideal for obvious reasons. So if we open up our score script, the first thing you'll notice, and you may not notice that it's the same on yours, but it's definitely like this on mine, is we have two squiggly lines under TM Pro and TextMesh Pro GUI. I don't know why this is. This isn't affecting our game at all, but my inkling I think what's happening is there's an error inside of Visual Studio messing with this because this is a new feature to Unity, to be native to Unity, and it's just an error inside of Visual Studio and nothing to worry about as it's not actually affecting our game. So if you see this in your project, don't worry about it, but if you don't see it, also don't worry about it, but it's all good. First thing we want to do is create a public, and we're going to make public int high score, not high score all. And we want to create a reference to the high score UI. So we can just copy this line of code and add high score. Awesome. And then it's pretty simple. All we want to do is say in update, we can say if score is greater than high score, then we can just save high score data. So how do we actually save data? Well, it's really simple inside of Unity. We can just use player prefs, and player prefs are really powerful and really simple and gets the job done exactly for what we need. So we're going to be using player prefs. So to use player prefs, all we need to do is write player prefs dot set int. So we're setting an integer variable, open parentheses, open speech quotes. We're going to call this variable high score. So it's either accessing a variable called high score, and if there is none, it's going to create a variable called high score. After the speech quotes, we press make a comma, and we want to just make it equal to score. Why are we making it equal to score? Well, whenever score is higher than a high score, well, then that is a new high score. So instead of then changing the variable of high score to score, we can just cut out the middleman and set an integer high score equal to score, because if score is higher than high score, oh my gosh, there's a lot of scores in this sentence. If score is greater than high score, then we can set an integer to whatever score is, and that will work perfectly fine. But what about actually getting the high score? Well, how does that actually work? Well, let's create a start method. Void start, and then we can write something as simple as high score equals player prefs dot get int, and then it's just asking what integer we want to get, what player prefs we want to get, and we just want to write high score. And as long as these are spelled exactly the same with the same capitalization, everything, it'll work just fine. Then all we need to do is write high score UI dot text equals high score dot toString. But I've just realized we have a problem here. It may not be obvious at first, but let's go back over to Unity and we'll see if we can discover the problem. So if we go over to our player, if we open up our canvas and open up our game over menu UI and go over to player, we can actually scroll down and we can see that we have an empty spot for high score UI where we can drag in our high score. So pressing play and pressing the play button, our score is 1, 2, 3, and die. Okay, our score is 0, but we just got the high score of 3. Let's restart the game. Press play again, die. Oh, now it's displaying our high score as 3. Well, what's going on? So it's actually saving the data, but it's not displaying it correctly if we get the high score on that round, if that makes sense. So for example, let's beat our high score again. Press play. 1, 2, 3, 4. Bam. It shows 3. It's saved 4, but we're actually still displaying 3. Well, why is that? Let's go over to our code and have a look. Okay. When are we adjusting the high score variable? Okay, we're adjusting it here, here, and here. The only one that's actually setting the high score integer variable here, the only time high score is actually being changed is in start, which only happens once at the start when this script is called. So we need to actually change some of our code here. So right down here where it says player pref set int high score equals score, we could do that, but to fix the problem that we're having now, a better thing to do would be to change the high score. So we say high score equals score. Cool. So if score is greater than high score, well, now high score equals score. Fantastic. And then we want to set our integer, and we could just leave it at score, but let's use high score just for consistency's sake. And let's go inside of here and say player prefs dot delete all. Just going to press play quickly. Bam, all our saved data should be deleted. Now we can delete this line of code. Go back, press play. When we run in, bam, should be at 0. That's exactly what we expected. Press play. And bam, it should equal 3. That is working perfectly. So if we restart it now and we press play and we die here, bam, our high score is 3. Awesome. So I hope that makes sense. When we need to save data, we're just setting an integer called high score and we're equaling it to the high score variable. And when we want to load the data, we're getting a high score variable and we're accessing player prefs and we're getting an integer and we're getting the integer of high score. And we're setting this integer high score to the player pref's integer of high score. How many times do I say score in this episode? Okay. Awesome. So now we have a working saving and loading system and our high score menu is working perfectly. In the next episode, we'll work on adjusting the menu to have a little bit of zazz, and that is animations. Okay, so let's jump straight into some animations. Right click and create a new folder called animations. And then we're going to work on the in-menu UI animations first. So we probably want our play button to pulse in and out. So we go over to our in-menu UI and go to play button. And we can just click over to animations and we can click create. It's going to ask us where to put the animation and we can just call this play button and save it inside of animations. Now animations are pretty simple to do. We can actually just press the record button and we can go to say 30, change the width to 500 and the height to 500. You'll see, maybe that's a bit too big, but you'll see that they will turn red and it will fill in the data here, the size delta data. And then we can copy these keyframes from the start so you can see it goes up. Copy these keyframes from the start and drop them in at the end here. And if we press play, awesome, that's our sweet animation. I think it's a little bit too violent, so let's go over to the middle keyframes again and let's say 450. Let's see how that looks. Jesus, still might be a little bit too, no, I think that looks fine for our purposes. Awesome. The other thing that we want to adjust is if we select our logo, we want to create an animation and we want to say logo. Save that. And once again, we want to press the record button so we can start at probably, at let's say 700. And then at 30 or whatever you think looks good, we can drop it down a little bit. And then up here we can say 700 again. Let's see what it looks like. I think that's a little bit crazy, so we can just use the scroll pad to just scroll down a little bit, and we can drag these right out, these keyframes. So I'm going to drag it out to say 150 and drag this to about there, and I'm going to actually adjust this up a little bit. Cool. So if we press play, that looks a lot better to me. Okay, so if we press play now, we see the play button moves and we see the logo move, but we want the balls to rotate as well. So if we unclick that and we click on our left ball, we can add a animator. Now this happened automatically before because we weren't using a child object that already had an animator. So we need to do this ourselves. So if we just add an animator clip and we click on our left ball, we'll see down here in the animation window, it now opens up a new, to begin animation left ball, click new animation clip, create new. We're going to call this left ball. Cool. And we just want to do some rotation. So if we press the record button, let's zoom out, probably want it at about 200. So if we go up to the rotation here, we can just go to the Z360. So that's a full circle. And then at about, say, the 2, we'll say 0. If we press play, awesome. So it looks good, but there's a little bit of dampening there. Well, what do we need to do? To fix that, let's go into our curves. And if we just scroll up, you'll see that our curves like this. If we grab this section down here, we can drag it up And if we grab this section here, we can drag that down. So it's a bit more of a straight line. And now if we press play, you'll see it's just rolling along as if like it's got no dampening or anything, just like rolling along in the wind, which is the effect that we want. Awesome. So we just want to do the same thing for the right play button. Click on right ball, add animator. We can click back over to our dope sheet. It's asking us for a right ball animation clip. Yep. Create a new one. Yep. Right ball. Sweet. Press the record button. Leave it at, put it at 360. We can go to 2, which is what we had it at, and 0. Go to our curve sheets. Awesome. Let's press play and see how that looks. Okay, so now you understand the basics. Adjust things to your liking, and I'll do the same. Okay, that looks pretty good to me. I'm happy with that at this stage. And this actually concludes the polishing section of our game. Everything is working pretty well, except for ads, but we'll cover that in the next section. But our game is working pretty good. All the buttons work fine. We can play, we can pause, we can play again. We can control everything. We've got animations working, and everything is looking pretty swell. In the conclusion, we'll talk about what we've learned over this series and just reiterate on a few of the design and coding decisions that we've made. And we'll also implement our Unity ads. Look forward to seeing you there. Welcome to the conclusion of this series. Before we get on to putting in ad support and doing the final few touches, I want to just go over the things that we've already learned. We've actually done a lot of stuff in this game, and it may not feel like it, but I just want to recap what we've done. If you've made it this far, congratulations. You're really awesome, and you're on your way to becoming a sweet game developer. We learned about installing Unity, setting up for mobile functions. We learned about variables. Then went on to learn about materials, player movement, how we can get the player to move with mobile input and controls. We got camera system working. We got a score system working. We got saving and loading working. We got random. We got the level to randomly generate objects in random places, and we got the level to continue on forever. We then started talking about shaders, cleaning up our code, audio, and then adjusting our menu and adding some animations. We've covered a lot in this course, and I hope it's been quite enjoyable for you. You'll be able to take these core principles and expand them into other areas and other games that you want to make in the future. All the code we've written in this game will work in pretty much every game. And I look forward to seeing some of the awesome projects you guys work on in the future. So in the conclusion section of this series, I want to touch on two things. I want to add Unity ad support, which is pretty important for monetizing your game. And I also want to touch on where we could go from here. What features could you add? What features could you remove? And what features could be cool and how you could approach them in our current game. So without further ado, let's get into it. Okay, so let's just jump straight into making some ads work inside of Unity. So what we want to do is if we press play and press play again, when we die or run into these spikes, we want to have the option to press this little button here and for us to show an ad, and then it gives us an extra life. But we only want this to happen once. And there's a little bit of logic that we have to code in there. But to first get started, we just need to move over to our services tab over here. And we just need to go to the ad section here and turn it on. Monetize with ads, your game. Sweet. We can click on go to dashboard, and that will bring us to the website where we can look at the information about how many people have clicked on the ad and things like that. And it will be linked to your Unity account if you've logged in. And so far, everything is looking good. We can enable test mode for development, and we can click back over to our inspector. Okay, so how do we actually get our Unity ads to work inside of our game? Well, first, let's open up our app initialize script. We could have our own script that deals with all of this stuff for just the ads. But I think because we're doing such simple ad functionality, it'll be fine to be in app initialize. So luckily, if we go over to unity3.com/services/ads/quick start guide, or if you type in the quick start guide for Unity ads, you'll see that we have some example code here. And you will see it even it shows us where we want to put our code, your code to reward the gamer, in here. So this code here is the simplest way to get Unity ads working. And you'll see that we need Unity ads.advertisements namespace, and you'll see a few things in here. I encourage you to read this guide to give you a more in-depth understanding of what we're doing. But right now, we're just going to jump straight in and get the ads working as quickly as possible. So back over to Visual Studio, there are a few things that we want to set up first. We want to add 2 namespaces using Unity engine.advertisements, using Unity engine.ui. Cool. And now we want to code in some functionality to just get the button to work at this stage. So to do that, we'll probably need to create a new, 2 new things. First, let's create a reference to the button. So let's just put that up here, just so all the menu items, the UI items are up here. And we can say public game object add button. Cool. And we need to create a Boolean private, just because we don't need to see it in the inspector, bool has seen rewarded ad. And let's equal it's false. Fantastic. So then if we scroll down to our game, to our show ad button here, you'll see that right now it says fix later, and then it just starts this at the coroutine, which is start game. Well, we can get rid of the fix later for now, and we can just write something as simple as has seen rewarded ad equals true. Cool. And we're just going to add a note that this is just temporary, because this is just for testing purposes, even though it was for testing purposes before, but bear with me. And then inside of game over, we want to create an if statement that says, well, hey, if we have seen the ad, we don't want that button to look or like it's going to work, and we don't want it to actually work either. So we can just say if has seen awarded ad equals true. Then we can reference a few things and just turn them on or off on the add button. So the first thing we want to do is say add button dot get component image, and we can access image because we're using the Unity engine.ui namespace. So add button dot get component dot image dot color equals new color. And then we just want to set red value to 1, green to 1, blue to 1, and alpha channel to 0.5F. So if you're not familiar with color, basically we're setting everything to be exactly the same color that it already is. So we're setting all the values, red, green, and blue, to 100%. And we're setting the transparency to half the transparency. So I hope that makes sense. Then we're just going to say add button dot get component button. And what do we want to do? If we've seen the ad, we want to say enabled equals false, because we don't want them to be able to press the button. All right, let's go over to Unity and see how that goes. So just so we understand, when we hit something and we press the show ad button, it's going to, what would happen here is we'd normally show an ad, and then it would turn this to true, but we're just going to turn it to true now because I'm not going to show an ad just yet. And then it's going to start the coroutine. But when this is true, when we bring up the game over menu next time, it's going to turn the color to 0.5 and make it so we can't actually access the button. So back over to Unity. Let's open up our game over menu UI. Heart show ad. Fantastic. Then let's drag the heart show ad into the add button section on the Scene Manager script, the app initialize script on the Scene Manager object. So let's press play and let's test this out. Play. Bam. Let's press this button. Cool. And bam. And now the button is no longer working, but we can still restart the game and press play. Bam. And it's back again. Awesome. So that works. So the functionality works absolutely perfectly now. And now all we need to do is get the actual ad to show. And that's actually a lot simpler than you think. So we'll tackle that in the next episode. So if we open up our app initialize script and we go down to our show ad button here, what we need to do is we can get rid of this. We don't need that anymore because we know it works. And let's go over to Unity Quick Start Guide. Okay, what do we need to grab from here? Cool, so we'll see here they have the public void show rewarded ad. And they just have one if statement in here. You can see they use a different style of coding than I currently do, where they put these down here than up there. That's just personal preference. It doesn't actually affect the code. If we press copy, we go over to our code, we can just dump that in there. I think we can actually get rid of this as well. So now it's throwing an error here, but let's go back over to our script here, and we'll see we've got a private void handle show results, which is the same thing that was being underlined. So let's just copy all of this, leave out the last one, the last curly brace, because that'll be the class. Copy that. And let's throw that under here. Now I'm just going to fix this up to be how I like it. Cool, so that looks pretty good to me. I think that is good. Let's press save. Let's go over to Unity. Because we've just copied some code from somewhere else, we just want to press play and just make sure we get no errors. Awesome. We get no errors, and we see we get this Unity ads initialize equals true here. So that's good. That's just showing that things are working. Well, if it says true, it says that things are working. And here we want to say your code reward to Game and Goes here, give coins, etc. Cool. So don't need that. And then we can just say has seen rewarded ad equals true. So just so everyone knows, a switch statement is very much like an if statement, but it's just switches through the results. And when it lands on a result, it doesn't continue and ask the next set of questions. So it's a little bit more, it's a little bit more friendly for like mobiles, or it's a little bit less work for the computer, because they're quicker than if statements as far as the CPU is concerned, but they're very much the same. But all you need to worry about is putting your code in between this section here. So we've got a few cases. We got case show results equals finished. So if we've finished the ad, it'll debug.log the ad has been shown. We turn the rewards to true, and then it breaks out. So it goes, all right, we break out of this and we just exit this method here. Cool. If you've skipped the ad, well, nothing happens, but you could put some code in underneath this. But nothing happens, and it just says the ad was skipped before the end. Okay. And then it breaks out of that. Or if it's failed to show, like let's see you've had an internet problem or something, nothing happens, the ad is, and it debugs and logs an error and says the ad has been failed to show, and then it breaks out of that. So the one that's going to happen the most is up the top here, and so it'll hopefully come to this. The ad will be shown successfully all the way through, and then it'll break out of the switch statement. So if that's a little bit overwhelming, you don't understand, that's fine. All you need to remember is stuff that goes in between this break and this case.finished is the code that will be run. So what's the next thing that we want to do? All we need to do is, it keeps trying to format it to like that, so let's just leave it. Start coroutine, start game. And we want to pass the time as, let's say, 1.5 seconds. So 1.5 S. Cool. And I'm just going to neaten this up a little bit. Ugh, I hate copying other people's code. Okay, I think that's how it's supposed to be formatted, but who knows? Doesn't matter, doesn't affect the game. That looks fine to me. So now if we go over to our game and we press play, you can see over here our enabled test mode is on. We can press play. Bam. Press the heart. This screen would be your ad unit. Awesome. So it's working perfectly fine. Press the close button. Waits 1.5 seconds and then continues on, and we can't press it. Fantastic. So that is now a functioning Unity ads system. And the last little thing we need to do is set some cool animations and make it more enticing for the player to press the hard button. See you in the next episode. Alrighty, so when we press the play button now and we get smacked by the big triangle, we want, when this button is available to be pressed, we want to entice people to be able to press this button. This is a good way to get people to want to keep clicking, keep clicking on ads. And we want to decrease the value of this button. So what we can do is when this button is available to be pressed, we can make it pulse and we can make this button look exactly how it is now. And then when this button isn't available to be pressed, it doesn't pulse, like animate, and this one does animate. I hope that makes sense. So to do that, let's go over to our in-menu UI. Let's turn that off. Let's turn Game Over menu UI on. Let's select our heart. Click over to Animation. Create a new animation. In Animations, and we're going to call this Heart Ad Button. Cool. You should remember what to do. We'll press the Record button, and we can change its width to, say, 200. Maybe a bit too high, maybe 175. We could probably drag that to 30. And then say 150, and then copy these and throw them up here. This should all be pretty familiar to you. Now let's press play. Let's see what that looks like. That looks pretty good to me. So we've got that animation. Fantastic. Now we can click on our restart button. Same thing. Let's add an animation. Restart button. Press record. And we could do a cool rotation thing. So we could do negative 360. And then scroll out to, say, 3:00, like that, 0. Let's see what that looks like. Cool, let's go into the curves and let's just make sure those curves are pretty straight. You can adjust things to your liking, or you can add a bit of a pulse to it if you like. But I'm just going to leave it like that for now because I think that looks pretty good. And let's go back over to our project. Let's go to our script and let's open up the app initialize script. Alrighty, so let's go down to the Game Over script here, and we just want to add a couple of other lines of code to adjust our add button. So some stuff in here. So we can say add button dot get component animator dot enabled equals false. Cool, and then we need access to our restart button. So come up to the top here. Public game object restart button. Scroll back down here, and we want to set our restart button dot get component animator dot enabled equals true. So what this will mean is when we have seen the reward, it turns off our add button from being animated, and it turns on our restart button. What that actually means is this one needs to be on by default, and this one needs to be off by default. So then we go back over to Unity, and we go to Game Over menu UI, and we go to our restart button, and we turn the animator off. So if we press play now, press play, bam. Cool, so right now it's tempting us to press this button here. We're like, oh, yeah, of course it makes sense. Press this button, right? It's not really tempting us to press this button. We'll press it, we see an ad, close the ad, waits 1.5 seconds, bam. And it's not working. Why is it not working? I hope everyone knows by now we forgot to assign it. So let's just drag our restart button in, test that again, press play. Bam, press an ad, close the ad. Awesome. So now we can't press this and it's tempting us to press the restart button. Well, it's saying, hey, this is what you gotta do. So we're teaching the player what to do subconsciously. The average person doesn't think about these things. And we can easily just press this button now and the game feels a lot better. So now we have a working game over system with ads implemented. Everything is working just fine. And all we need to do now to make this production ready is when we are making it production ready, all we need to do is unenable test mode and then we're ready to rock and roll. We can export this and put it onto both iOS and Android. And the Unity ads will work just fine. It really is just as simple as that. See you in the next video. Okay, so in this episode, we want to finish off our player. Our player right now is just a generic sphere, but we actually want to change that because we've got a model of our player, so we can use two different materials. So if we go to our player and we can see all things that our player has on it, if we just turn this off and we can rename this temp, and then we can go to our models and we can drag our player in. You'll see that our player is probably too big, so let's make the scale 50 by 50 by 50, rotation 0. Cool. Now you'll see that if we click on our model, we have two materials here. We can extract these materials and we can put these materials inside of our materials folder. Cool. If we go over to materials now, you'll see that they're here. And if we change them to curve world shader, everything will fit nice and snug. Beautiful. Now, if we press play now, nothing will happen, but basically our player is moving forward like this and not actually rotating. We need to actually code in some functionality for the rotation. But for us to actually test this out and to work, we need to put over all the components on here to get it to work correctly. So we need a sphere collider, a rigid body, player, script, a score script, and an audio source. So let's do that. We can actually copy the components by moving over and just copy component, paste component as new, copy component, paste component as new, copy component, paste component as new, copy component, paste component as new. So the reason it's good to copy instead of just creating all new components is because then it fills in all this information. The only other thing that we'll need to do is go over to our camera and we can actually drag our player into this section, our scene manager. We can actually drag our player into this object spawner script here. And we can also drag our player into this app initialize script here. And we can make sure our player is tagged as player. And then you'll see when we play the game and press play, oh, we die straight away. Why is that? Let's have a look. So our player has, I see what the problem, I know what the problem is. So we have a sphere collider here and that sphere collider has come over from our other game object, but you'll see that now, our sphere collider is actually huge. And the reason it's so big is because we copied it over from our last, let's remove that. We copied it over from our last game object, but this one is 50 times larger in scale. So we're just going to add here's another sphere collider. Cool, and that looks good. Let's just press play. Awesome. So scoring works. Getting hit works. Awesome. Everything looks fine, except our player doesn't actually rotate, which was happening before. It's just that our material didn't show that was actually happening. So to fix this, let's go into our player script and add some code. So scripts, player. So underneath our line of code here that actually moves our player forward, we want to say transform dot rotate vector 3 dot right. I think right will work. And we want to times that by get component rigid body dot velocity dot z. So that is the speed that we're moving in the forward direction. That's how fast we want to move it, but maybe divide that by 4. So it's just not so fast because that'll be a pretty fast number. So if we go back over to Unity and we press play, so everything's at 0, 0, 0, 0 on our new player object. Awesome. Cool. If you wanted our, so that works as we would expect it. If you want things to move faster, we can get rid of this or change the number there. Go back to Unity, press play. And you can see it's quite fast. And you'll see that when we stop, if we go over and we go to player, you'll see it's actually stopped as well, which is what we want. But I'm going to leave that at divided by maybe 3. It's a bit faster. So that looks like. Cool. That was pretty good to me. Now we could actually, if we wanted to rotate this, say we wanted to rotate it 90 degrees. What we could do is we could go into here instead of say vector 3.right, say vector 3.forward. Because remember now it's rotated. And we could press play. That's a little bit trippy, but you get the idea. Awesome. I'm going to revert that back to what we had as before. Cool. I'm pretty happy with that. So now we have our new model in the game. I'll just want to get the player and just make this 0 again because I like it to face this way. And we don't actually need our player temp anymore, so we can get rid of that. And let's just play test, make sure everything is working A-okay. And everything looks to be working fine. If we crash, press and add. Awesome. Cool. Everything seems to be working fine. So there you go. So we have our new model in the game, which has different materials. If you actually go into the materials, you can change obviously the color of these if you wanted, do a different color. But I'm just going to leave it at the color that was because I like that. And yeah, there we go. So I'll see you in the next episode. Okay, so before we tie a bow in this project, I want to go over a few core things that are vital to this course. And that is that everything that I've taught you to do so far has been me just showing you instructions and then you typing in those instructions. But where I want to really encourage you and where a game developer goes from basically a novice to someone who can make their own game is by experimenting and adjusting things and trying out new things. So what I want to do is explain to you a few things that I think that could be done in this project to make it way better. But I'm not actually going to show you the explicit way on how to do that. But I'm going to point out a few design decisions that we could make. So, for example, if we play the game now, and we press play again, the game very quickly gets boring. And why is that? Well, it looks impressive. I mean, well, it's not, God of War or anything, but it looks okay. But there are a few little things that just don't sit right. So right now the ball kind of rotates only in one direction, but it'd be cool if it rotated with the horizontal axis. It also, right now nothing else happens in the game, so this game gets boring very quickly because we're dealing with the same objects over and over and over again. So basically the player has one choice. The player has the choice to move around the objects, and that's it. Well, there's a lot of middle sections here. So the player has a choice to just move away from objects, and that's all the player has to do. But where game design comes in, and how we can make this game a lot funner, is if we had more conflicts for the player to resolve. And what do I mean by conflicts? So, for example, if we were coming along, let me just press play and then let me pause it again. So if we were coming along and we had the option between these two to also pick up a coin or to pick up a power-up, but let's say the power-up was here, a player might risk running into that these just to get the power-up. Or let's say we wanted to make it so there was some coins that sprinkled down, or let's make it so we wanted to make it that certain power-ups made coins come towards you and they gave you a point. Well, this would give the player options. The player isn't just going through yes, got through that one. Yes, got through that one. Yes, got through that one. They have to make the decision, and in a split second of time, do I want to go for the coin that's here that might put me at risk, or do I want to play it safe and go through here? Or what if it's a special coin that gives you 5 points, et cetera, et cetera, et cetera. We want to give the player options on how to be the best at the game, if that makes sense. We want to give them ways to be better. And right now, our game only has one way, and that is to repetitively play the game. Now, don't get me wrong, this could be good game design. Games like Flappy Bird were so simple, but they played on the idea that you died so quickly that you could restart, and it was easy to restart. And that was actually really good game design. But for something like this, you'll need to, I think it's better to actually put another conflict in. So another thing that you could do is you could make it so the speed of the player actually ramped up over time. And these are actually really easy things to do. So let's jump over to our player script, for example, and we got our player speed at 1500. But what if every single frame we just said player speed equals player speed plus 0.1 F. Let's just see. Go over to Unity and press play. So right now our player is going along, but it'll gradually get faster and faster and faster. The problem with this though is eventually it'll get so fast that it will be unplayable, like literally unplayable. But I'm not sure if you can tell, but things are actually getting faster and faster as we go on. Good way to tell is if you just look at the numbers up the top there. So even there, with that little bit of a speed improvement, I actually noticed a little bit of a difference in how the game felt. The game actually felt like, oh, it's ramping up to something, something's happening. But this actually won't work in the long run because obviously it'll get to a spot where players can't get any better. So what you could do is you could wrap this in an if statement and just say, well, if, player speed is less than, and you just pick the fastest amount, and then you increase the value only if, in that case. So that's something simple you can do. Another thing you could easily do is you could make it so you could create an object, create 3D sphere. Let's just go to the sphere, move forward. Let's give it a random material because we know it's curved. Let's just change the scale to be that of a coin. And obviously you can get it to rotate with some code. We've done this before. But cool, we could just set this trigger here. And then we could add a tag and we could call it coin or something. Then we come over to our score script and we can say, if other damage tag equals coin, then score plus plus or score plus 5, whatever you want to do. So things are really simple to actually, and we're just going to delete that. But things are really simple to just adjust this game and make it a little bit better and make it a little bit fun. The other thing you could do is you could make a character select system. We can select different players with different colors or completely different objects altogether. You could make it so you could collect invincibility power-ups. And these power-ups, all they would do is you'd say, once you've got the invincibility power-up, then you can say, get component sphere collider dot enabled equals true, and then it just stops you from being able to collide with anything. but that will mess with your score systems. So you can come to the player script and you could say something like here and go, you can say, and, so two ands make it's a condition where both these things have to be true at the same time, and is invincible equals false. And you create a variable, a Boolean called is invincible, and that turns on when when you've got the power up, and then turns off when the power up runs out. So these are just little ways that will probably be overwhelming to deal with at the start. But once you start trying to implement them yourself, know that you've got this base plate and you're not going to screw up anything. Maybe copy this project and dump it into another area in your computer, and then just play around with things, mess around. What happens if you add some coins? What if you want to spawn at random locations? Once again, if you like, okay, I want to actually spawn some random coins, well, you could go to object spawner script, and you could create some more prefabs, and you can just see what we've done here in the past. Okay, so we're going to spawn a triangle, and we're spawning the triangles at our spawn obstacle position .z plus 30. Well, you could do the same thing but plus 15, and you could have it, spawn at a random location. My point is that game development is tricky when you first start out, but the best way to get better is to try new things and see if you can get them to work. And the best part about working inside of Unity is you can go to Google and you can just type in something as simple as how to make a coin magnet Unity, and you'll get you get hundreds and hundreds of results where people have had this exact same discussion, trying to come up with a coin magnet, trying to come up with the invincibility, trying to come up with a character select system, and you'll be able to find other people's scripts that they have let people just use or they've discussed together. And you'll be able to look through the code, and hopefully you'll have the skills to be able to take some of that code out and try it out in your game. And it may not work, and it may work, but the grind is how you get better. If any of you guys are new programmers and you've gotten this far in the course and you actually end up implementing new functionality, please, by all means, somehow get in touch with me and show it to me. Send me a message over Twitter, contact me however you want, and just show me what you've done. I really love to see the results. Besides that, join the conversation and let's discuss some cool features that we could add to this game. In the next episode, we'll touch on the final project tidy up and the release settings. See you there. Okay. So our game is pretty much complete, but we want to check the settings and just make sure everything is all good. So the first thing we want to do is we want to just play our game and see if it works fine inside the inspector. Just play it for a little bit. Awesome. Now we want to go over to our console and we'll see our logs here. Okay, Clara is working. Alrighty. So let's double click on that and it'll open up the appropriate script. And we'll see we've got a debug.log here. We don't need that anymore, so we can just delete it. It's just unnecessary overhead at this stage if we're about to release. Press play again. Awesome. So everything is working good. Fantastic. Then we want to actually go to our player and make sure we unmute the theme song here, the audio source. Okay, so now if we press play, we have our lovely music back. Awesome. So that works fine. Then we want to go to File, Build Settings. And we want to run in Xcode as release. In Android, these settings will do just fine. And we can go down here and go down to Player Settings. We can set a company name, product name. We can build our default icon and default cursor if we want to, which I don't know will be necessary for mobile. We can set up our icons in here. They'll tell you that it'd be 180 pixels by 180 pixels or 120 pixels by 120 pixels, etc. You can go through these settings and you can say, well, I only want it to be landscape. I only want it to work in portrait. We don't need it to work in portrait upside down or landscape right or landscape left. And these will all be a little bit different depending on depending on if you're building for Android or for iOS. But basically, they're all set up pretty well how you want them. But I encourage you to go through these and check them out. anyway. However, I say all this, but when we export out of Unity, so if I go File, Build Settings, and I click Build, and I'm just going to dump it onto the desktop in a folder called Build. It will take its time to actually build the project. But what's actually happening is it's not actually building the game that will work just perfectly inside of iOS or Android. It's actually building the iOS Xcode project or the Android Studio project. So, what does that mean? Well, there's an old saying in game development that I think I invented. But basically, when I first created my first game, Galaxy Cube, in 2014, I thought that once I exported out of Unity, I could just easily upload it to the iOS App Store and everything would work just absolutely perfectly. And how wrong I was. There were tax forms I needed to fill out for Japan. There were certain certificates I needed to download. I needed to prove that my computer was a worthy computer. I needed to do all these specific things for Apple to get my app onto the App Store. I needed to pay a fee of $150. Android, it was much easier. I just downloaded Android Studio. I opened the project in Android Studio. I followed the steps to complete things, and then I just uploaded it, and within 24 hours it was there. So even if you don't get all the project settings perfect in this build, it's important that when you put your game over to Xcode or to Android Studio, that you can adjust them there. Now that my project is built, I can open it up and I can see that this is the actual project that I would open up inside of Xcode. Now, because I'm on a Windows computer, I'll need to actually open this inside of a Mac computer, and I'm not on my Mac at the moment. But if you had an Android, if you built an Android app, it'd be similar, and you'd be able to just open it up inside of Android Studio. So if you're on Android, I suggest typing in developer Android Studio inside of Google. It'll come to a page like this, and you'll just be able to download Android Studio and open up your project and follow the steps to get it onto the Android store. There is an entire manual here that you can read that will help you go through the step-by-step process, and the same goes with Xcode here. So you can download that if you're on a Mac and install your game onto your phone and start testing out to make sure everything works perfectly before uploading it to Apple or to Android. Now, why aren't I going through all these steps inside of this course? Well, because these steps change all the time. If I release 2 games on the iOS and I release 2 games on Android, if I was to, and I've got a lot of experience messing around with these 2 companies, if I was to create a new game and upload it to these stores right now, the first thing I would do is come here and start reading this manual here, because they're always changing the standards and you can't really keep up. So the best thing I can suggest that you do is you come here and you read exactly what needs to be done. It's the admin part of game development. It's the boring part of game development. It's the frustrating part of game development. But once you get through this last little bit of fire, your game will be on the App Store or on the Android Store, and you'll have a game that you'll be able to show your family and friends and say, hey, I made that. How awesome is that? So all that's left now to do is to download Xcode, download Android Studio, get your app working on a phone, test it out, make sure everything works, and then follow the prompts inside of Xcode or Android Studio and get your game on the store. Congratulations. Making it this far means you are now technically an indie game developer because you have developed an indie game. I know it may not feel like it's your game because you followed a tutorial, but like I said, you can add your own little bit of flavor and your own little bit of things, but you've now been able to see a project from start to finish and know exactly what goes into making a game. You'll be able to take these skills and the things that you've learned and the code that you've learned and the techniques that you've learned and put them into your own projects that you think up by yourself. I'm looking forward to seeing what you guys do with this project, and until next time.